by the way.
Welcome,
Damn,
YouTube. It is SuperForce
awesome.
Sunday.
Dude, I
I'm
think
joined
you're
by,
gonna sell a lot of those. Okay, never mind.
right?
I would buy 3. I'm not kidding.
Yeah,
Fucking
I told you I'd send you one
anyway.
for free.
No, don't. I don't want you to do that. That's it costs you money, bro.
Yeah,
I,
yes,
I
that's true.
regard
I'll
you
put
guys
them up for
like my
sale
own
on the
freaking
site, maybe.
family. You guys are like my family, and anyway, trust me, I'd come on APAC if I could, but I was anyway.
Yeah, didn't you get?
Come on, go ahead.
So you had any problems coming on my show? Did anyone give you crap about that?
Oh, dude, I had emails. Dude, I hunted this guy down. I forget what's called Jared something. No, not Jared. Something something media, some sort of media. It went back to Wikipedia.
Yeah, they went and edited.
And
Saw
you
that.
know in whose pocket Wikipedia is. Dude, it's heavy. And they really hate us.
Yeah.
All of us that have different ideas because we're changing the narrative and they hate us for it. Anyway.
Yeah, well, it's like all the old timers hated Max Planck. Didn't he say science progresses one funeral at a time?
That's right, my brother. That's right. That's like, yeah, I shouldn't wish death upon anybody, but you know what I mean?
But hey, it's Veterans Day yesterday, right? So
right.
we have a veteran here. Jared Yates is also.
Thank you for your service, sir.
Thank you for your service, and thank you for being here to join us. Don't you have a disclaimer to make about the affiliation with your former employer?
Oh yes, sir. Thank you for this. May I call you brother? I'll call you brother.
Yeah. From this point forward, we're going to call each other brother during the rest of the podcast.
Okay, no more. Yeah,
around with Ashton, and he kind of just proceeded to call you sir for the rest of it. But that's not going to happen here.
No, man. I hate when they call me Dr. Pais. It makes me feel old. Like, where? Where's my father? No, I'm kidding. Anyway, dude, yeah, let me give the disclaimer. Okay. So are you recording?
Yes, brother. We are live now.
All right.
We're live now, man.
All right, let me see how I phrase this. Okay, I come on your. Thank you, Jeremy, for having me on your podcast, Alien Scientist, brother. All right, I come on your podcast as a private citizen, and my opinions, my speculations, my statements are my own. They have no implication upon the United States Navy or the United States Space Force, and as such, we shall. Oh, and also, I hope that I can retain the prerogative to not answer certain questions or not in a dismissive manner, but politely say that I'm given this particular medium. I would rather put it this way: I'm not here to educate or enlighten our enemies. Period. Thank you.
And I bet you we have some of our enemies watching, no doubt.
Oh, you can bet your booty, baby. Let me read that thing from Kerson Huang, because it was, unless you have, you want to introduce something or something like that, because I don't want to, I don't want to, I don't want to put a disturbance in your flow, if you know what I mean. So if you have something on your mind, go ahead, but let me read from that book because it's important. In my opinion, Dr. Kerson Huang of MIT, I believe he's deceased now. He was emeritus at the time he wrote this book. The book is called A Superfluid Universe. Kerson Huang, his last name is spelled Huang, first name Kerson, professor, MIT, I believe physics, known for the Huang potential in quantum field theory. Let me read from this book to see exactly what this man says about dark energy and dark matter, which after all supposedly represent almost, what is it, Michael? Almost 95% of the so-called observable universe?
I don't remember off the top of my head, but it's around there.
Yeah, so it's quite a fraction. It's the major. So basically, we have no freaking clue what most of our universe is composed of. That's interesting. So they tell us that physics is almost over, that we have accomplished great things. I think physics is in our infancy. Oh, before I start with Dr. Huang, let me do a little plug on. I've been on 2 recent podcasts. You guys, please, all of your subscribers, all of your followers, please go and see Ashton Forbes, the interview with him on his new podcast called Hard Truths, Truths, Hard Truths. I was his first interview. Good guy, very, very intelligent, very interesting story to say on a certain aircraft disappearance. I'll leave it there. That's his baby. I'm pretty sure one day he shall prove it. Certain people will dislike that very much. And I hope they do not cause him any harm. Again, Ashton Forbes and I, Salvatore Pais, who never suicide ourselves. Now, what was I gonna say? Yes, and the second is it's called Demystify Psi. So it's Demystify. I forgot how you spell that. I think it's MYSTIT. Anyway, I suck at spelling. Sorry. So Demystify Psi, like SCI, the abbreviation for science. Podcast. It's with Dr. Anastasia and Dr. Shiloh, and I think it's worthwhile. It's 2 hours and 37 minutes. 2 hours and 37 minutes. So let's beat that. Jeremy, come on, bro.
Yeah, that one was great, man. I've watched both of these in preparation for this interview, so there won't be a lot of overlap. We'll try to cut down on some of the stuff. Maybe we'll give a little bit of summary of what was discussed in some of these, just real quick.
Sure, sure.
This was a great one. People should definitely go and watch this and subscribe to this channel because these guys are super underviewed. I'm going to have Anastasia and Shiloh on coming up at some point here in the future too, to promote their channel a little bit more.
Anastasia is amazing, and so is Shiloh. But Anastasia, she actually went to a thesis advisor and said, "Unless you tell me what the nature of electrical, what is electrical charge, I refuse to continue work on my thesis." I mean, talk about wow. Anyway, I'm sorry, Jeremy. Go ahead. Sir.
Yeah, there's so many fundamentals and stuff, and they do a great job of bringing it back to those things and questioning those ideas and some of these issues. So definitely go check that one out. And then Ashton Forbes, he's the other channel there. I had Ashton on as well. Definitely a smart guy. Got me asking a whole bunch of questions about, what does a Bose-Einstein condensate or a superconductor look like under thermal imaging? And, we should
ask Michael Perrone. As a matter of fact, I suggest if Ashton is watching right now, have Michael Perrone on. And of course, Jeremy and Jeremiah Pop, have them on. Anyway, this is what I call the future of science and engineering. Thank God we got you, bros. And thank God you're young. The enemy has a lot to worry about. Anyway, sorry, go ahead.
So I also have, we got a bunch of these patents. I want to get through the patents individually. I want to ask a couple questions about some of these patents in specific.
All right, but let me start with the superfluid universe first. I got to read this from Kerson Huang.
Yes.
Trust me, we owe this to this man. This man is a good friend of Freeman Dyson. Again, Freeman Dyson, the man known for the S matrix, the first to unify the works of Richard Feynman, Tomonaga, and Julian Schwinger as far as the basis of quantum electrodynamics. If it wasn't for this man, for Freeman Dyson, forget about it. When nobody would understand QED, trust me, especially Schwinger's work. Wow. Anyway, what was I gonna say? Yes. So Kerson Huang, an incredible, brilliant man. I think he hit on what exactly dark energy and dark matter is. Please let me read from this. I've even marked the page. I have so many notes in this. My God, you should see the margin of this book. I remember one time it was Pierre de Fermat that said that he actually found a very simple proof to his Fermat's last theorem, but the margin of his particular book, it was too narrow for him to actually give the entire proof. Can you imagine how? And then how? Anyway, I'm diverging again. Okay, so let me read this. Oh my goodness, this shows that I'm an old dude who needs additional enlightenment over here. Okay, so listen to this, man, because really we'll talk about the intersection of quantum field theory, general relativity, and condensed matter physics. Listen, please. Nature, however, does not know about our subdivisions and exhibits phenomena that cut across all our specialities. I find such a situation in the great puzzles of our time, dark energy and dark matter. These phenomena may find explanations in the fact that the Higgs field of particle theory and or an extension of it fills all of space, making the whole universe a superfluid by virtue of the dynamics of its quantum phase. In short, we propose that dark energy is the energy density of the superfluid, and dark matter is the deviation of the superfluid density from its equilibrium value. And gentlemen and ladies who are watching this, out of equilibrium phenomena. So when you drive things out of equilibrium, it seems that it talks to not only dark energy, but dark matter.
Would that imply that all of the areas that have excess dark matter might already be populated by some other species?
Oh my goodness. Wow. That's profound, brother. I didn't. Again, thank God you're the future, man. You know, nah, I didn't even think about that. Yeah, sure. That, oh my God. That's a very, why
Or
win?
there could be natural phenomena as well that use up some of
Axions.
that energy.
You know what I'm saying? All these machos, whims, axions, blah, blah, blah. I'm not saying let's stop looking for it because there are billions of dollars invested in this rather interesting experimental work. But remember the axion work, this is not Frank Wilczek's original axion. This is a new breed, something that I think, I forget her name, Kathy Fries is working on. She was on Brian Keating recently talking on the axion experiment. I've tried to get on Brian Keating's podcast before. Actually, someone asked him about my work and he like dismissed it out of hand. Him and I share an alma mater, man. At least out of, you know what I'm saying? Case Western Reserve University, we both graduates, alumni of it. I mean, give me a chance over here, brother. I don't know, man, but if he ever watches this, come on, Brian. Come on, man. Otherwise, how am I to prove that Pais science is not pseudoscience? But if you don't,
this is the thing is so many of these people they're relying on so hard on theory, and theory's good to a certain extent. A lot of it's based on a history of experiment. But really, I'll let Richard Feynman say it as he said it best.
To discuss how we would look for a new law.
Right.
In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh. That's really true. Then we compute the consequences of the guess to see if this is right. If this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
Yep.
And that's
Experiment trumps theory every time.
Absolutely. And now the whole issue of gravity, there's a lot of theories out there on gravity, quantum gravity. You know, I love that spiel that Kurt Jamungle did when you did your first interview on theories of everything, where he laid out.
Kudos to him, and a plug for his show, Theories of Everything.
Yes, absolutely.
Really good show.
I'm going to bring a couple other people in here really soon, too, that are waiting in the back room now that I played that clip. So let me introduce some friends.
Michael, you and I eventually have to discuss the room temperature superconductor. Look at that paper that Jeremy archived, Victor Lagno's paper. Look at his last page, how he basically says that it's we'll talk more on it, but it basically, it says that I use an alternating magnetic field to disrupt the surface superconductor material. And then because a Bose-Einstein condensate really forms, then I use an alternating current to dynamically move the condensate.
Right. So there's a few engineering particular questions about that. I get the theory side.
We'll talk more. Yeah, we'll talk more. I mean, you are the real material scientist. I just touch, you know, I read a lot, man. I'm a jack of all trades, maybe master of none, but at least I think, man. I'm not afraid to freaking think. You know what I'm saying? Some people are afraid to go to even just, you know what? What do you mean thinking outside the box? How about you make the box disappear? Totally open system. Anyway.
Can I just go back real quick to the superfluid universe that we were talking about? I can't help but observe the similarity between the older concept of the ether as well as pressure differentials in that, like scalar waves or longitudinal waves in the ether, and the pressure differentials that you're talking about in your thing. That was all.
Very good observation, guys. Let's not forget the original Maxwell equations, 20 equations, 20 unknowns written in quaternion, so vector plus scalar formalism. Talk to what? Dynamics of a what? Cells in what? Ether. But nobody wants to talk about the luminiferous ether because they think Einstein did away with it. Read 1921's paper, Einstein, how he says we need the ether. Space-time without a dynamic ether could not exist. How come nobody cites that paper?
See, the thing is, so I think the point of confusion in mainstream physics is that you had the Michelson-Morley experiment, which was very publicized, and people assumed that because the ether or the material medium in which electromagnetic waves propagate has no reference frame of its own, that must mean it has no material properties. But precisely a material made of virtual particles can obey covariance from different reference frames.
Right on, brother.
So you can have a material made of virtual particles that's still generally covariant. And the reason that we as observers observe a constant speed of light is simply because particles are still light. They're just solitonic. There's nonlinearities added that stabilize the particles. But if they're still fundamentally electromagnetic, if all the forces are unified, then they'll still be affected by that local refractive index. So an observer made of particles will only ever see a constant speed of light. They'll bend along with the curvature, or the refractive index, I should say.
Think of life. Let's bring biology into this. Life is a far from equilibrium, out of equilibrium, nonlinear phenomena. Without that, we wouldn't exist. Doesn't that say something? We really are an emergent, right? Life is sort of like an emergent property out of. I gotta read. We gotta discuss what time is. I gotta read. After I read this book, A Superfluid Universe by Kerson Huang, dude, I came up with this. Listen to this, okay? Time may be an informational energy collective field, whether it is emergent or fundamental, will depend on the nature of the collective fields involved. And I also say time is an energetic property of nature that prevents everything from happening at once. You're muted.
I like
That's interesting. I need to think about that more, because you have thermodynamic time, and then you have physical time in terms of particles interacting and scattering and stuff. And I think thermodynamic time and physical time might not be the same thing fundamentally.
If that's true, then what do you think about Wheeler's single electron theorem, that maybe, it's just one electron that's bouncing around the entire universe, making all these loops?
It's what put Feynman on the whole idea of the path integral. It's what gave him the idea that basically brought QED into birth, the birth QED.
A photon is a superposition of half of the energy traveling forward in time towards a destination, and half of the energy traveling away from the destination backwards in time.
Right.
You can't physically, there's no way to tell which it is.
Remember what Feynman said of the positron? What's a positron? It's an electron that travels backwards in time. That's right. That's right, Jared. You know.
And then the thermodynamic time is a little bit different than that, though. So you've got forward and backward in particles, and you can do that at the quantum scale. You can do that just fine.
What do you think of Eric Weinstein's idea that there may be multiple dimensions of time, just as we have multiple dimensions of space? Like Hilbert space is n-dimensional as n approaches infinity. What if time is similar?
Absolutely. If I can just jump in on that real quick. Especially when you're talking about your Schwinger levels, and space-time is getting like squeezed in one way, but not the other way, and you start getting birefringence. Now you have a different aspect for time in one direction than the other. You get it spread apart far enough, and from the local reference points between the separated charges, you actually have zero time movement going on.
Right on, brother.
David Chester backstage looks like he was.
Very good. Very good, bro. Jared, nice.
Hey, David.
Hey, how's it going, everyone?
Hey, a legend. What's up, brother?
Hopefully my microphone's working.
The only other man out there that thinks Jack S. Anyway, is a great mind. No, anyway, never mind. Yeah, let's leave it there. He thinks of my work. Oh my God, Dave, man. Anyway.
Well, he has a lot of thoughts.
It's strange because his Sarfati field looks identical to yours,
It's very similar, yeah.
Dave, you're a little bit too loud.
I remember when I first heard Dr. Sarfati speak, it reminded me of something my grandma used to tell me. Said, keep your words soft and sweet, just in case you have to eat them. Do you think Jackass over there eats alone? No, I'm kidding.
I mean, who does he collaborate with?
Anyway,
hey, you know what? I got Jack backstage too, so no, I'm just kidding. No, I'm not just kidding. This is gonna get crowded real fast, man.
Dude, he's a smart dude, but come on, man. He's got to give people some. You can't excuse my language. You can't call people, idiots and expect them to love you. You know what I'm saying? It's human nature.
Yeah.
Am I right or am I wrong?
He's that sort of Brooklyn personality type of,
Yeah, but come on. Lenny Susskind, Brooklyn plumber, for goodness sake. That's what he started as a plumber. You never hear him. I mean, the guy is like the epitome of gentleness.
Well, there's kind of two different ways to be insulted.
The same way.
Here's a great question from the audience. We got a $20 super chat. This Drake89 wants to know, are large lasers like they have at Lawrence Livermore a viable approach to exceeding the Schwinger limit? And there was a division that's still classified to this day called Q division, where they built these really high-powered lasers and they pointed them at each other.
Bravo, Jeremy! I applaud your knowledge of these stuff, dude. Do you know how few people? But anyway, look. The bottom line is this. Just think of it this way. I'm not going to answer the question, but in a way I'll answer it, but in a way I won't, because I have to be careful. Remember my disclaimer. Again, we're not here to educate and enlighten our enemies, right? E-cubed. We're not here to do that, brothers. All right? They're enlightened enough. They got us in the crosshairs. But anyway, look, the bottom line is this. The physics, you will know, Dave, come on. The physics prize for this year, what? Attosecond lasers for electron dynamics. Need I say more? And what do those 10 to the minus 18 second pulses do? David, you know more about this than I'll ever. but you know exactly what I'm talking about. Of course, they're gonna be used for certain things. And by the way, attosecond lasers, just like femtosecond lasers, but much can be used to create something called cold plasma, out of equilibrium plasmas, non-thermal plasmas. So anyway.
If I can just jump in and answer that question real quick, you might want to look up, to the person who asked the question, you might want to look up the SLAC linear collider experiment E144. That was the experiment done in 1995 and 1996, where they produced 100 particle pairs. It was a inelastic process, though, so it wasn't a true Schwinger effect, but it was close enough. It was a great analog of it. Highly recommend looking that up. And that was in 95 and 96. The second part of that is the Dolphin experiment from 1980, where they exploded a nuke, funneled all that energy into a laser. The energy density of that experiment was getting damn close. And then that was 1980. So you can safely assume beyond that, the experimental possibilities, especially for the black world, were definitely capable of breaking the Schwinger limit.
Interesting.
Yeah, and it's a very real process. And if you consider that atoms themselves are high energy density, that gets you a lot closer to the Schwinger limit.
Can I bring it to the Superforce equation 1? I don't know, Dave, if you've seen this. You know, it's such a freaking small paper, 3 pages, just 3 pages of very simple math compared to the math you do, brother. Oh my God, you know. But anyway, you know, very simple crap. And equation 1 basically says the superforce, which is c to the 4th divided by big G, equals the energy gradient at both the Planck scale and the horizon scale, right? But that's not the key. You can basically say, you can extrapolate, because I'm an engineer. That's the truth. I wish I had great physics pedigree, because maybe then they wouldn't reject my freaking papers like every 12 hours. Anyway, you know, I don't want to get
well,
that.
so it's not an exact equality, but you're arguing that it's potentially of order of magnitude, which is
on
a
the order,
curious
right? And
observation.
that means they hold on all others. So if you put in that equations in the mass, so it's basically the superforce is on the order of a mass. Say it's the mass of the proton, c squared, divided by some reference length that has to do with how the superforce treats the proton. Guess what? We get the Schwarzschild radius. Schwarzschild, I can never pronounce it. The Schwarzschild radius for the proton, 10 to the minus 54 meters. You know, the 2 big G m divided by c squared, that one. We get that. So in other words, the superforce treats the proton like a black hole, bro. And if it treats the proton like a black hole, how about the other particles? Anyway.
So were you aware that that equation is a reformulation of Dirac's large number hypothesis?
Really? No.
I fooled around with the math.
I swear I don't.
Yeah, so
oh my God,
it
no,
literally,
it's totally original. I mean, from my perspective.
No, it's a curious observation. I mean, I'll be frank, the paper reads a little wild.
Excuse my language. You're right. Oh, holy crap.
I'm not surprised that a lot of academics wouldn't want to read it. There's a lot of wild claims in it in regards to quantum mechanics. But I thought there was 2 interesting observations in that paper. Maybe a lot of other things I would have ignored, but the first interesting one was exactly this, your point you're making. I mean, I reformulated the equations. It literally, you can argue it's a reformulation of Dirac's large number hypothesis, which has been a sort of, I mean, it's this controversial idea because it's a little numerological sounding, but then Paul Dirac thought of it. So it's like, well, he's not a crazy guy. So what do we do with this? And it has been a popular idea somewhat amongst kind of more interesting thinkers who are, you know, outside the box, let's say. So I thought that was curious at least, but yeah, I thought you made maybe 2 strong statements to say it's like equal. So that might mislead some people to think that you're maybe saying something overconfidently, but I mean, it's something to explore. Maybe there's something there, maybe not, I'm not sure. So it at least seemed plausible for that one aspect of it.
I appreciate it, Dave. Thanks. I appreciate that. But what did you think of the when I was able to show based on the fine structure constant, I mean, did you see how simple you can prove the gravitational force equals the strong nuclear force at the Planck scale equals the superforce?
I thought that was a bunch of nonsense, to be honest. I didn't
boy.
understand what you're saying whatsoever.
Well, I mean, the equations.
Maybe I
I
can-
looked into the numbers at least, and I saw that. I mean, all the numbers just off Wikipedia, they match up at the very least. So you got that.
Jeremiah.
But yeah. So what he was saying, I think, David, is at the roughly the radius of the proton, or at least of nucleons, that's where the strong force is approximately that much, 1/137 or 137 times stronger than the electromagnetic force. And I mean, there's a lot of people who've mentioned like,
No, it's at the Planck scale. We're not talking about 10 to the minus. We're not
well,
talking
initially. So you have to connect it first to the. So the strong force is 137 times stronger than electromagnetism at the length of at the radius of roughly nucleons. But then when you go down to the Planck scale, then they are equal, and g to the c over 4th is. But
I mean, it depends on your normalization scheme, probably. So
how can you have the strong nuclear force? So how can you have the highest force we've got that we know of that operates on the order of, at 10 to the minus 15 meters? How can you have that force at 10 to the minus 35 meters be equal to the gravitational force at that scale, at the Planck scale, right? Equal to the superforce. You can't unless the superforce is the force of unification.
Well, right.
What does that even mean?
What David's saying is 1/137 doesn't stay the case, and for a lot of models of quantum mechanics, as you get smaller and smaller scales, the strong force or the relative strength diverges. It gets larger instead of smaller because, well, if you consider like the strong force is sort of like a Casimir force between the protons and neutrons and things, then if you consider it like that, then as they get closer and closer, that force should keep increasing, diverging away from electromagnetism. But yeah, I mean, mathematically, at least, when you take these equations and draw these ratios, then yes, you get the same thing. But yeah, that's what David was saying towards renormalization, right. I think.
Yeah. What was the other thing you liked, Dave? What was the other thing you liked?
Well, I mean, the first section and the last section, but frankly, the last section was it was very short. It was what, a paragraph or two, and all.
I mean, talking about engineering the superforce, that one you like?
Yeah.
Okay.
So I mean, which is very similar to what Jack Safrati's claiming, but I mean, you've also had patents that go back as well.
Yeah.
I mean, I don't know. In terms of the stuff in the middle of the paper, I thought that even your earlier paper or your earlier patent in 2017 at least had a more coherent attempt at talking about like vacuum energy and stuff. I mean, like the 2023 SuperForce paper.
Look at the Schrodinger equation and how can you get basically from that equivalence of, I don't know what you'd call it, but read carefully that section. How can you get one of the equation you get E equal h nu? The other equation you get is the Broyle, basically, lambda equal, on the order of h bar divided by mv divided by the momentum. And the other one you get is a superforce, basically based on the rest energy gradient. So again, pointing to equation 1. And dude, GR itself, you basically, if you reorganize based on just a simple dimensional analysis, because you have 1 divided by L squared on the left side, representing the space-time curvature, is on the order or equal, it depends how you want to treat it, 1 divided by the superforce times the C sum nu, which is really what? E divided by L cubed as an energy density. So if you reorganize, which is very simple from a mathematical standpoint, it actually says it's the superforce acting as a scalar operator on the space-time curvature that gives rise to matter, energy density. It's that freaking simple. So it's a new perspective on old physics. That's what I'm arguing for. And you know what this talks to? And I know, Dave, you how should I say? Look, bro, I really respect your physics. I mean, your mathematics is far above my level. It's true. And you are what? Quantum research. I mean, you deal with Kerwin. I forget his name. God Almighty. Who's
Clee Irwin.
Clee Irwin. I mean, this guy is fascinating. I mean, but your mathematics is unbelievable. Anyway, so what I'm trying to say here is that all I'm trying to get is some acceptance that I'm not a freaking crackpot, that this is not pseudoscience. Just take a closer look to what I have to say rather than just dismiss it all of a sudden. Do you know that the physicists, they won't talk to me? For example, I started a conversation with Stefan Alexander. You know Stefan, good friend of Eric Weinstein, also Brian Keating, a good friend of Kurt Jaimungal. But anyway, at least he knows, you know. And I sent him all the papers. That podcast really went really well. And I thought he never even responded to my emails. That shows you, I mean, if
everyone's busy
on a lot of things. You saw that
podcast. Yeah, it could be that too.
After you see that podcast, would you call me a crank and a crackpot? The truth.
Yeah, I would love to get into plasmas.
I don't mind if you tell me the truth. Tell me the truth right here.
I don't think. I think everyone's a human. Like everyone's always asking, is he a genius or a crackpot? And I mean, I think most of these cases it's somewhere in the middle.
I'm neither, but I'm someone that should be heard. Am I right that people should be heard with their ideas?
Everyone should be granted freedom to, express their voice, and then everyone should be granted freedom to listen to whoever they want.
Yeah.
Don't feel bad. Professor Alexander didn't respond to my Instagram request, so.
I was wondering, Mr. Pais, sir, I was wondering if I could very briefly.
I'm not on social media, so if you ever send me like LinkedIn or whatever, I'm not. If you get any emails from someone that says it's me, no, I'm not on any social media. And Jeremy can testify to that. I mean, I'm freaking so old school. I still use a flip phone. Anyway. Yeah. All right.
I didn't even think you were a real person at first back in 2018 when your patents came out. I'll be honest, and it wasn't until Brett Tingley sent me confirmation that I was like, all right.
I love Brett, man. I wish him and I kept close, but after I have a feel between you, and I'm gonna say it. I mean, what the hell? I'm already in their crosshairs. They don't like me. Period. Trust me, especially the 3-letter ones. I have a feeling Tyler Rogway. Put it this way, he had a lot to do with my work being called UFO Navy patents. And dude, once you call them that, once you call them unacknowledged flying objects, okay? Once you call them that, not UAPs. Come on, Jacques Vallée, you can do better.
Jeremy, could I jump in really quickly? If that's cool.
Yeah, absolutely. This is Mike Rossi of was it your channel?
Dave or David Rossi, yes. Mr. Pais, sir, I am a great admirer of your work.
Call me brother.
I'm a great thank you. I'm a great admirer of your work. I just had one thing I wanted to sort of ask/say, and then I'm happy to sort of bow out a little bit. So we see that in 1957, Li and Yang won the Nobel Prize for the broken symmetry of opposite charges. Yeah, right. We see that it's been speculated that stabilization of disequilibrium could potentially be tapped via the third Heaviside component or a third time derivative. And we know that closed current loop symmetry restores, closed current loop circuits restores Lorentz symmetry, basically throwing out the use of the A field. And so, do you think it's possible, sir, we have
brother.
Sorry about that. Sorry.
Thank you.
I'll say very briefly here. We have many mutual friends. I was curious if you think that utilizing this third Heaviside component longitudinally may in fact enable some of the effects that you have, which I fully personally agree with, pertaining to breaking of symmetry with mass and inertia and all of that. So, do you think there's something there in that regard with the third Heaviside component? It's been speculated there's an entire basically wire, if you will, that misses the circuit that very few engineers are familiar with.
I'll give you my Francis Urquhart response, so I don't give you the disclaimer crap.
Sure.
Francis Urquhart coming up, okay? You may possibly say so. I couldn't possibly comment.
Thank you, sir. Brother, thank you.
You're welcome, sir. By the way, tremendous mind over here, man. All you guys, do you guys get up in the morning and like sit on the porcelain Buddha and read all the freaking what's it called, the physical review letters, all the latest papers? Because I used to do that. I bet you guys do too.
Actually, if I could, one more thing, Sal, one more thing, if I could ask, would you say that the Feynman's path integral may in fact lead to this axis of the superforce? It's been proposed that when these longitudinal waves are hit, there's this sort of caduceus-like break apart that occurs. Would you say that there may be something there?
If Dave agrees with the statements, I would say yes.
Okay.
But only if he does. Otherwise, no, nothing.
Thank you.
I'd have to think about it more. Sometimes it takes a little bit of time to just get the terminology synced up to 100% verify.
So, Dave, you were talking about longitudinal things. Is that like in terms of the if you don't have the gauge potentials of, or if you don't fix the gauge potentials of electromagnetism, and that gives you a
in other words, Michael, yes, sorry. What I'm proposing is following the work of Myron Evans, Terry Barrett, Pudov, Mr. Pais, the notion of a generally covariant higher symmetry second order effect that gives rise to things like quadrupole mass oscillation that you can then use to curve the geometry of space-time, which would be a gravitational wave. Yeah.
Okay. So this isn't simply the second wave equation that comes out of electromagnetism if you don't hold the gauge.
No, there's an entire Heaviside component that's been thrown out in like the late 1880s that seem for some reason. I mean, okay, if you look, for example, there's no textbook in North America.
Mr. Rossi, brother, listen. Following your statement, I gotta follow with a statement to show you how simple this all can be.
Right.
And it brings into question, how long ago was this known? Is the work of Walter Bosley, Dr. Joseph Farrell, other luminaries correct? Are we dealing here with a possible breakaway civilization of sorts?
Well, have you seen Sal E.T. Whitaker's paper from 1903?
And I'm not talking about Richard
I've studied that in great
he
detail,
my work. He loves Eric W. Davis, so
David, you've seen E.T. Whitaker's paper of the bidirectional scalar.
I've studied that to great detail.
Those two papers that he wrote in 1904, I think those two
1903 and 04.
Unbelievable, man. This guy was, again, almost dismissed. Very few people know of those two papers.
In my opinion, that work merges the world of the non-material with the material, basically. Yeah, there's a beauty to it in a certain way, in my humble opinion. But if I could say very quickly, Michael, what you were discussing, the notion is that essentially because of the A field that Feynman had talked about, the potentials, you can essentially use the del cross operator both theoretically and then practically in the lab to induce a caduceus-like axis along the z-axis to give an absolute to have absolute motion instead of relative motion. So you now have your own, dare I say, gravitational field being emitted from the 0 point.
Oh, smart people here.
Wouldn't the chirality of that be important?
Sure, I believe that there's a way to stabilize it, in my humble opinion. Very much so, absolutely. The chirality is very significant. I think when things are done in the lab practically with things like liquid helium, you can start to get some very interesting results. Let's just put it that way.
Yeah, agreed.
So it sounds to me like you might be talking about two different aspects. I'm not sure, but in terms of that Heaviside term, I'd be curious to see if that's the same thing as Ampere's law. Like Ampere's law isn't actually the work of Ampere. And so if you look at what Ampere actually did, there was a term, this longitudinal term, that got dropped because they couldn't, if you had two open circuits,
Lorentz,
they dropped.
Sorry to cut you off. Lorentz said that it has no physical significance outside of the right angle vector, and they threw the baby out with the bathwater, and it was a complete mistake.
Right.
Basically, because Lorentz said to Maxwell, "You'll never get quaternions across to the engineers at the time." So he said, "You got to stop it." He said, "You got to get it simpler." So
that's why we love Heaviside.
Right. And that's why, if you look, by the way, there's no textbook in North America that talks about the magnitude of the Poynting vector. At best, they'll talk about potential intensity, but not the magnitude of a potential.
Right.
So that's, I'm speaking in code, Sal, if you catch my drift.
No, I do. And don't call yourself humble, brother. Your knowledge is very extensive and very, very particular as well, which is interesting, how he can bridge the two worlds. But anyway, listen, GM theory by Dr. John Brandenburg, very interesting idea of what the Poynting vector represents. You know, this man actually was able to show the Higgs, we talk about the mass of the Higgs before it was even, whatever, experimentally shown, if you know what I mean. Yeah. Look at his gem theory. It is quite a gem. Paul Murad had a lot to do with that as well. It's the Murad-Brandenburg equations. I really miss Paul, man. The only person that actually returned a very kind, when he read the conditional possibility of spacecraft propulsion at superluminal speeds, that paper that I sent you, Jeremy, you put that in the archive, right? I mean, I wish it was in the archive, but anyway, yeah, it'll never see archive stuff. But anyway, in that paper, he said, goodness gracious, this belongs in a much better journal than, what I eventually, after 4 years of back and forth, I was able to publish that. That shows you, man. But listen, your ideas, Mr. Rossi, sir. Well, I can't remember your first name, so I call you Mr. Rossi.
David, but
I say brother, we're all brothers, so it'd be like, which one?
No, you can say David, by the way, but no, whatever you like, yes.
So the physicist is Dave, and you're Dave, but you sound like you have quite a physics background.
I'm self-taught, sir.
You're kidding me.
No, I'll leave it at that for now. If you want to
talk, I'm saying, this is what I'm talking about right here. This is what I'm talking about, because I said it on Ashton Forbes. I said it on Demystify Sci podcast. I said it, and I'm saying it again. Joe the plumber can freaking publish in Physical Review letters. It shouldn't be based on pedigree and who you know and how much you kissed the of the chief editor and all that, and who you. I'm sick and tired of this hierarchy. Okay, and the more you talk, the more waves you make, the more it tears you apart, and they have nothing to do with you.
Sal, can I ask you a quick? Go ahead. Question, Sal. Do you think that if hypothetically, do you think that if these longitudinal waves existed, that they would have a sort of caduceus-like coil around them, if you will, which speaks to the red shift and blue shift of what's been seen in UAP?
I'm starting to think that we should go back and studying vortex dynamics. And Dave knows what I'm talking about. Yeah. In the beginning, they were studying heavy-duty vortex dynamics before all of a sudden it just disappeared. I have a feeling that's very essential in all this. Don't forget, James Clerk Maxwell, what? Cellular vortices in what? In ether? Luminiferous ether? But anyway, yeah.
Right.
Yeah.
Right.
Can we go?
So when you mean caduceus coils, are you literally talking about caduceus, like the coils that someone made with the 90-degree angles in it?
Basically, I'm proposing, as is Sal probably more than me, that the metaphysics and physics merge very eloquently.
So I'm just trying to connect this to physics I'm familiar with. So
sure.
So basically, you have some crossed fields, and people assume that those crossed fields superimpose, but perhaps you're getting an outer product.
You gotta curl the Poynting vector, basically.
Right. So add a curl to your scalar potential, and then you get this natural self-assembling formation where if you already have a vector direction, and you're putting that vector into an area of space-time where, say, you have an active cold plasma or something on those lines, the kinds of experiments I've been playing with, and you oscillate that longitudinally, you get self-assembling structures that tend to be vortexial and sheathed. So they're like mini Birkeland currents. You'll get one counter-rotating current around the other, and they'll tend to wrap up on each other and self-assemble. Then if you rip them back in the opposite direction quickly enough under a magnetic field, they form these really complicated little structures called toroids. And they will form a torus inside of a torus inside of a torus, continuously wrapping themselves up into more and more complex geometries fed by the energy they're stealing from the outside low energy cold plasma conditions by basically rectifying the randomized background particle flux of all these virtual positron electron pairs that are partially separating. So you get kind of rectification of the background field, which is, I think, one way that we can access Planck scale interactions by using longitudinally pumped waves through an active plasma.
Jeremiah, have you seen Memes and Instructions channel? He's got some stuff you should definitely see then.
Probably I should. I have not.
Yeah, he's got this figure 8 knot thing that seems relevant to that maybe. But yeah, okay. So you're saying so it's not necessarily, Dave, a outer product term that gives you a pseudoscalar. It's actually longitudinal waves, not scalar terms yet.
I'm saying when you implement the A field or the ether or the vacuum, whatever you want to call it, into the equations or the
experiments. Yeah, you know what? I've noticed terminology matters. So let's stick to quantum vacuum. Let's not use things that they no longer, because that's why they call us crackpots and charlatans and whatnot, because we don't use sometimes the proper terminology. Let's play the game. Let's play the game.
It's so important. You gotta connect it to the terms that are fashionable in science and whatever given you.
Is using Dirac C still fashionable? Or do we just want to say quantum foam? I mean, there are many choices.
Dirac C, well, we can ask Dave because he is the actual working physicist. I mean,
that refers specifically to, I guess, the positrons in some sense, or that's referring specifically to Dirac spinors, whereas the quantum vacuum would contain fluctuations from all quantum fields. So
it's a collective field, right? Yeah.
The Dirac C is still a fashionable term, but it doesn't refer to everything.
The idea is that the quantum vacuum would act as a negative resistor, so to speak, if that makes sense. That's kind of the notion that I'm following, Michael, if that makes sense. And implementing the quantum vacuum with practical experiment, electromagnetically curving.
Is there experimental evidence of this negative?
But remember what Dave
resistance?
said? That they're different fields. How do the electromagnetic fields interact with these fields? See, that's where the problem resides. How, at what level do they interact? Dave, can the electromagnetic field interact with all fields we know of? Yes or no?
No, it interacts with charged particles. So gravity interacts with all of the energy and momentum, but electromagnetism only interacts with.
That's what I was afraid of. Mr. Rossi, sir.
You can, once you get into quantum processes, though. All right, actually, once you get into QED and you're, sorry?
Also, I was going to ask you, never mind. Go ahead. I'll let you finish with it.
Well, all right. So, yeah, I mean, if you look at things classically, you need to interact with photons. You need to have something with electric charge. But once you get into the quantum theory, then you have all these loop corrections, these quantum corrections with loop diagrams or the Feynman diagram. So then you can have more convoluted processes that might allow you to have to consider what theory, right? So it's like photons don't interact with gluons, but photons interact with quarks, which interact with gluons.
Well, can we, if I can jump in very quickly.
Wouldn't everything at least interact with the stress energy tensor still?
Right, but if charge parity inversion is equivalent to reflection, then you can manipulate that, in my opinion. To your point.
I don't know what that means.
Points. Charge parity inversion, as Dr. Myron Evans, Terry Barrett, and a few others had talked about, charge parity symmetry is equivalent to reflection.
Well, there's typically
if you can have some type of condensate parity. Forgive me, sorry. If you can have some type of quantum state, condensate, excuse me, that can interact with say polarizable conductors, capacitors, etc. At extremely high frequencies, you may be able to break some of that symmetry having to do with.
So, Dave, is it possible under certain conditions to make certain fields interact with fields that they would not normally interact with?
I would say so. In my experiments, yes.
I mean, it's such a vague state. It's hard to, it depends on the context of what you're starting with and what you're ending up with. Yeah, I was comparing like quantum theory to classical theory, but that's not really irrelevant. I mean, everything interacts with gravity, right? Everything interacts with everything in quantum field theory, but those interactions get very weak due to they're more convoluted, right? If something can interact with something which can interact with something else, then the first thing can interact with the third thing through the quantum vacuum. So in that sense, unless you had two sectors of matter,
there's a transistor
don't interact with anything, but everything interacts with gravity. So gravity, once you put gravity into the quantum field theory, that should allow for everything to interact.
There's a transistor called the
very weak. Dave, do you think there's such thing as gravitons? And if they exist,
yeah, they're gravitational waves.
Do you think they may be related to photons somehow? Between the spin 1, spin 2 interaction.
I don't think so as much as Michael Perrone, but I mean, if anything, the spin connection is more like a Yang-Mills field, which should be unified with other Yang-Mills fields.
Right. But under certain coupling, say Yukawa coupling, is it possible that these may be photon in nature, something out of phase? See, Feynman, Freeman Dyson did not believe in the existence of the graviton. Do you think Freeman Dyson was correct?
No.
I take the quantum field theory perspective. I'm just very much trained in that, and to me, like my thesis computed gravitational waves using Feynman diagrams of gravitons. So my statement is that LIGO has, you could argue whether there is actually, maybe gravity is fundamentally different and doesn't have this particle-like aspect, but I mean, I use gravitons to compute gravitational waves as detected by LIGO. So to me, they're gravitational waves. Now, if we want to talk about photons, I mean, that's a different force carrier. So then that brings us into the game of unification. And then, obviously there's not a consensus on how to deal with that. I tend to think that they're a little bit different to some degree. And but here's the link. So we were mentioning Whittaker potentials. Well, the Whittaker potentials are encoded in Hertz potentials, and Hertz potentials are often overlooked. And Hertz potentials are mathematically, in a sense, more similar to the space-time metric than electric and magnetic fields. Electric and magnetic fields are more like field strengths or curvatures. The electromagnetic potential is more like a connection, like they both enter covariant derivatives. I know this is getting technical, but
it's good. It's good, Dave. This is beautiful language. This is the language we must speak in to be understood and perceived as actual, how should I say, professionals. So I agree with you, Dave. You use this language, sir, please.
So your patent in 2017 talked about the Gertzenstein effect.
Yes,
and there was
the Gertzenstein effect. The 1960 paper that he published, I think it was in a Soviet journal at the time. Yeah.
All right.
It was very controversial, extremely controversial.
As far as I can tell, it seems fairly reasonable. I mean, I just spent like 2 hours looking into your patent yesterday, but with that effect,
so
basically
it's feasible the Yukawa coupling could actually be the trick here. So in other words, could high frequency gravitational waves be generated, in your opinion?
I think they could be, but it's so weak. I mean, it looked like your 2017 patent, it looked like you were claiming that you can create a magnetic field that's 100 million times stronger than any other human on Earth. So if you could do that, then I think you could do a lot of interesting technological things, such as propulsion. If you can make a magnet that's
harness a magnet
100 million times stronger than anyone has ever made, then maybe we could do something.
Efforts to get that past the USPTO. This patent examiner, this primary patent examiner, amazing dude. I mean, he really knew his physics. His name was Philip Bonzel. Dude, we went back and forth, but you see, just look at Maxwell's equations, the Heaviside version. We're talking about 4 equations, 4 unknowns, the ones we electrical engineers can use, like Carver Mead. Basically, did you ever see this book by Carver Mead called Collective Electrodynamics? The Quantum Foundation of Electromagnetic Fields. Beautiful book. So beautiful, like under 200 pages. This, again, even he is treated by his own people because he's not in the right section of physics and so forth. You know,
wasn't he at Caltech at one point? I mean,
yes. Well, he's one of the.
But at the end of the day, like, I mean, yeah, he had a nice book, but I don't know. His claims seemed a little over the top to me. I mean, he had these simple way of looking at things that answered exactly the questions he was interested in. I mean, it's not dismissed. People consider it. It's just not the most important textbook ever. I mean,
experiment trumps theory every time. At least give it a chance for experiment. That's what I'm saying.
But he didn't even say anything controversial, really. I mean, he just presented the theory he just took a different perspective and took this collective excitation view, and he was trying to make the theory more accessible. That's my read of it. I don't think he was really saying anything controversial.
Emergence, just like Phil Anderson from a condensed matter physics believed in emergence, macroscopic quantum coherence. It's huge, bro, and I think it can be realized.
So, what were there any predictions of his work that led to that have so far been untested in mainstream science, at least?
I'm not sure, to be honest. I mean, it sounded like he was just trying to describe standard accepted physics, and he was trying to not go into too much quantum mechanics detail.
He was trying to
make it easy to understand.
He was trying to link the gravitational the gravitational field with the electromagnetic field.
Okay, maybe I didn't read that.
Trying to say that one can alter the other under certain conditions. That's the bottom line of I call it the little green book. And in my opinion,
I didn't read far enough.
Looked at very carefully because this guy, in my opinion, is extremely brilliant. I mean, we talk about one of the geniuses of the semiconductor technology. You know.
Yeah, I mean, he's definitely he knows what he's talking about. Yeah.
Guy, you know? Anyway, yeah.
Maybe I didn't read far enough. I didn't realize he had.
Give it another look, for my sake. Give it another look,
sure.
and you'll find something quite remarkable in there. But there was also a beautiful. Oh my God! He gave this very short. It's on YouTube. I bet you, if you Google it, you'll see it on the primacy of physics, on how we teach physics nowadays. It's like half an hour, but it's so brilliantly done. I'm not sure how it was received, but you have to see what I'm talking about. It's Carver Mead. I think it's right after a major conference or something. It looks more like a dinner, and then he goes up and just gives a speech for half an hour, but it's so freaking profound. I think I've watched it like 10 times. I can't believe I forgot the title of it, but it's so profound. It's just gorgeously thought through. Dude, man, look, the bottom line is this. We're talking about 4 equations, 4 unknown, simple, heaviside version of Maxwell's equations. You know, the EB fields, the surface charge density, the current density, blah, blah, you know. So look at Faraday's law, and you'll see what I mean, simple scaling dimensional analysis. So you have the curl of the electric field vector on the order of minus dB dt partial, right? You do a simple manipulation is E, right, divided by reference length on the order of what? On the order of dB dt, right? Which is what? B, like B divided by a reference time. So then really what that says, when you reorganize the thing, it gives you what? E max divided by me max. Again, scaling from the point of view that you take extremes. So E max divided by B max equal what? C. E equals CB is one of the things that Maxwell found, along with C squared equal 1 divided by mu 0 epsilon 0. That's what truly defines James Clerk Maxwell's rendition of Faraday's, man, dude, that dude Faraday, unbelievable. But this third equation, Faraday's law, basically says E equals CB. This is what I'm talking about, the power of scaling, simple back of the napkin calculation that gives you that. You don't need to solve the freaking equations. Boom, it's right there. It's in your face, it's physical. This is what I like, simple math, not abstract, complex mathematics. How should I say? passing for extremely great physics. Now, I'm not saying that's not needed, because most likely that's the next step once you understand the physicality of the problem from simple mathematics. But this is what I'm saying. If this idea and noticing this thing was able in 1890, what if Bosley was right? What if, I mean, I watched Jeremy. I watched your episode on this thing with Bosley, and he talks basically of like a, and Jeremiah there, Michael was there too. So you know what I'm talking about. This whole, it's almost like an out of equilibrium plasma being excited. I'm not sure exactly how he was excited, but again, it's the engineering of the Prigogine effect. We're talking about non-equilibrium thermodynamics here. Remember the whole idea of order from chaos, the whole idea of organizing highly dissipative structure, highly chaotic structures into something that has order, that is able. Dude, check out this. Google, I bet you it's still there. Time, comma, structure, fluctuations. Time, comma, structure, and fluctuation, something like that. It's the title of his Nobel lecture in 1973, Ilya Prigogine. Dude, this guy, I tell you right off the bat, this guy hit it right on the head. And that's what the Pais effect is all about. It's really the engineering of the Prigogine effect. That's
so
all.
If I can see if I'm understanding this this Pais effect, or this basically the scalar term that we're adding to general relativity, it makes not the stress energy relationship you got the stress energy tensor, but then you have stress energy entanglement so you're minimizing or maximizing entanglement entropy with this macroscopic quantum coherent state, and that is affecting gravity. Is that roughly the case, or am I off here?
No, Dave knows the formula well. Is G sub mu nu is on the order of, or equal, 8 pi. See, a lot of people go for natural units, but when they go for natural units, they usually leave out the c to the fourth term. I go for dimensionality because it speaks to the physics of the problem. So leave the dimensions in there, please. Okay, not for the sake of mathematics. Do this. G sub mu nu is on the order of 8 pi big G times T sub mu nu. No, don't get rid of c to the fourth, because it talks to a 1 divided by the superforce. Once you bring the scalar operator on the other side, so it basically says it is the superforce acting on the spatio-temporal geometric structure that gives rise to energy density, hence matter. That's the main point of what the superforce represents. It's just a new, and Mike and I have said it many times, this is not new physics. This is a new perspective on old physics. That's simple. Really, that's all that there was.
Right, because this superforce is just the Planck force. I mean, you have Planck units, so all Planck units get set to 1 in the natural unit system, and then so you could look at what are the Planck force, what units correspond to a Planck force, and that's what you're calling the superforce. So it's probably worth mentioning that the conventional view, well, we don't know exactly what quantum gravity is, but conventionally, we don't look at the Planck force as being a literal force. It's just units, dimensions it's just constants that you can put together that have the dimensions of a force. Whereas
but I think that's where we're going wrong. I think that's where we're going wrong. I think we should look to the physicality of it. Why? The Planck force is the only Planckian so-called, whatever you want to call, parameter. The only Planckian parameter that doesn't have h bar in it. There's a reason. It acts as a bridge between the realms of the very large and the realm of the very small. Hence, it is the bridge that could be the way to quantum gravity. It should be looked at. This c to the 4 divided by big G, I think it's extremely important.
So are we sure that? So how do we know for sure that this is only scalar, or I mean, at least Jack was saying it was only a scalar term in front of the. Like, is it possible that you could multiply the stress energy tensor by a higher rank tensor than just a scalar and still get an additional stress energy tensor, and thereby you would have some space-time properties that are not isotropic?
Yeah, I sent that idea to Jack, and then he said he thought of it.
Are you kidding me?
You
see what I'm saying? And you think when I say jackass, you know, I'm being mean?
But
look, the guy cannot call people idiots and expect them to respond, how should I say, with flowers. I'm sorry.
Yeah. But anyways, let's just talk about the physics.
Okay, yeah. Let's go back to physics. Okay.
Yeah,
so
if you look at
for now, if you get Maxwell's macroscopic formulation, it has like D and H for the free charges, and then you have the total charge. So you have this notion of free charge and bound charge, summing up to total charge. So Jack kept saying, I mean, I was inspired by Jack. He kept saying, we need a theory of gravity inside matter. We need it. So I just thought, okay, what about the macroscopic formulation of Maxwell's equations? Can you make like a macroscopic formulation of general relativity and claim that there's free and bound stress energy momentum? If you were to do that, then you could get this 4 tensor to convert. You could get this equation that has a 4 tensor instead of the scalar that Jack has. I mean, I don't know if it's the right theory. It's just something simple that you can write down. That's pretty easy. But yeah, so I mean, we shouldn't just say that Jack's idea of the scalar is definitely the way to go. I mean, we don't like. He has a few ideas. So now that's one of his ideas, I guess, right?
Something.
So,
let me ask you something. Oh, also Michael and you, Jeremiah, also you, Jared, Jeremy, get in. Everybody that has something to say, get in on this one because it's important. What do you think of his idea that you can use a freaking 3-volt DC battery to power that thing that flies, that TikTok thing?
The low power
MGH is larger than that for that given object. So I mean, I imagine you'd still need to apply at least amounts of energy associated with the potential energy of the object.
Also, he's not the first to make the claim that you can make the UFOs perform with such low power. There was a document back from the 60s where some engineer on the thing said that you could do it with a AA battery, that you could generate enough of a difference in the charge. It's not about the joules, it's about the difference in positive and negative.
Look at equation 7 in my plasma compression fusion device paper. That was the only one I could get published in a pretty good journal. It's the IEEE Transaction on Plasma Science, that one. Look at equation 7 very carefully, and you'll see what I mean by resonance bringing about a condition whereupon it's possible to get energy amplification. So when I saw that, it's like part of me said, no way, and part of me just reminded me of equation 7 in that paper. I tell you, there are a lot of things that seem practically impossible that turn out to be possible again under certain conditions.
So
is Jeremiah still dude?
Jeremiah's here.
Okay, bro, listen. Please, I think your ideas are absolutely brilliant. I mean, and dude, the spectrum of knowledge you have, if I had a hat on, I would really take it off. But listen, and I mean this, Jeremiah, I hold you in very much admiration. So just from now, when you speak, please speak as if you're talking to a like a non-English speaker, like bring, what's the word I'm looking for? This is, God forbid, this is not out of disrespect. I'm just saying, speak slower so people like Joe the plumber can understand exactly what you're saying. I think that's so important because what you have to say is so, sometimes I think it's incredibly brilliant, but sometimes my brain, I'm freaking over a certain age, so if you speak slower, I bet you a lot of people would be absolutely in admiration of you, just like I am.
That's like a really, really kind thing to say, and points out only what 100% of all my friends have ever said to me, which is, dude, slow it down. You just need to slow it down.
Okay. No, for real. I mean, see, the only time you would want to speed up your speech is if you have nothing to say and you're afraid of being found out. But in your case, you really are brilliant, bro. So just, you know.
Well, thanks. Probably giving me too much credit. I mean, everything that I know is just based on what everybody else has taught me. So it's
man. But
reiterations of their stuff.
What do you think science is? What, dude? The word genius. Do you know where it comes from? It means touched by the jinn. It comes from Islam. It comes from an entity of smoke and fire called the jinn. D-J-I-N-N. The jinn. That's where it comes from. Genius, like touched by the jinn. Supposedly these entities, if they touched you, they would invoke certain powers, you know, the whole thing. But anyway, I'm going into, or is it myth?
Oh, anyway. I love etymology. I think it's super important to understand the roots of words and know where they come from. It teaches us about ourselves and about how we came to the conclusions and the terminology we have now. Seems to me that most of us agree. We just use different terms to describe the same darn thing.
Bro, I want to hear you and Michael's and Jeremy's take on this. They also but you are the physicist in the house, as they say. So certain things you cannot talk, because otherwise you're kind of, anyway. See, I can get away with a lot of crap that you cannot. But anyway, look, the problem is that, I mean, what do you think about this stuff that they have changed the terminology from UFO to UAP? What's this phenomena thing to you? What does it mean? Why do you think they made this change? And they're trying to, how should I say, almost change the narrative on this.
I think really the big reason for the change is
freaking history. Am I right or am I wrong?
Oh, you're exactly right. I think the terminology had to be changed because every single time we get a new term out there and it's not properly defined, it just becomes another version of like the word God, for example, which every single person on Earth is going to have a slightly different way to explain. So UFO had such bad history behind it, and it meant aliens, and it meant, you know, guaranteed all these other contexts that were attached to it. By recontextualizing to UAP or, you know, new terms, we're trying to get away from all the baggage of these other older terms. And
so you think it has to do with derision, that this was something that was done? What do you think, Jeremy? Because Jeremy and I think we vibrate on.
It works on a couple different levels, because I mean, on one hand, you have the people that are saying that they want to destigmatize the term of UFO and try to come up with a new term to move forward. But I don't understand why object is, you know, that's a more serious term than a phenomena. So it's kind of just like, I don't know how it's helping with the stigma, really, especially when nothing's really changed with the evidence and information that they've provided. Because, I mean, you're the one that should be getting in front of Congress and like they should have you, you know, up there.
Let me tell you something, Jeremy, over here, right here. First, this is a first on your podcast. I hope this doesn't explode against me and tomorrow I get fired. But, you know, F it. This has to come out sooner or later. I was in the Russell Senate building on several occasions. But supposedly Eric W. Davis made sure that I didn't get any further. I was told certain things. So, but anyway, yeah, he had a lot to do with it. He's not, how should I say, the greatest of people. I'm sorry. On the Kurt Jaimangal interview, I gave him a break. You know, he did a lot of things against me. I found out that, put it this way, there was a team of a technical staffing committee team, highly placed people. We're talking about GS-15s and some of it above. And you know, GS-15, as you well know, is supposed to be the highest, but there is something above it. Not SES, it's between SES, so Senior Executive Service, and GS-15. They are the technical staffing of usually the Senate Armed Services Committee. Also, the House has one too. But anyway, they were sent when these patent applications, you know, when those things from the War Zone Drive, so Tingley and Rogway and the rest started, there was someone said, why was all this money, $500,000 over 3 years for 15 people, you know? And we took there were times that I did not even charge. I was charging out doing something totally different, you know. Just so my peeps, the experimenters, the guys, you know, hands-on like you guys are, not me with my freaking theories, but the actual guys that did the work in lab. Thank God, you know, man. Thank God they exist. But anyway, they send this 4-member team, very high technical dudes. We're talking about above GS15, below SCS, but still very high. They send them to see what were these things all about. So they meet. Yeah, this was a whole day thing that went on. And they went, they talked to the NAVE Invention Evaluation Board and said, why did you pass this, guys? And they basically told them, because we couldn't say anything. These were NAVE fellows, the best of the best Navy can offer, okay, at PAX. So anyway, dude, they basically proved to these guys that these weren't scams. These weren't disinformation. These weren't pseudoscience. That there was something that should have been looked at, should be looked at. I'm not going to say other things that followed, because a lot of things followed. And eventually, people will know the truth. And the truth, brothers, will make you cry. When I say that I had tremendous misery of the mind and the soul, and the blood, sweat, and tears went into this, I'm not kidding.
Yeah, I feel you there, Sal. Let's
Can I just say something?
One day all this will be superfluid. You know?
Forgive me. Right before I go, I just wanted to say something to leave everyone with a thought here. And what I'm about to say is not against anyone in particular, so I won't mention any names. But and I'm speaking on my experience here. There seem to be certain scientists in the community at large that publicly are claiming certain things don't work, while they're also privately working on the things they say publicly won't work. So I'll just leave it at that. But I want to thank you guys all for having me. And Sal, sir, it was a pleasure.
Likewise, brother. Please don't be a stranger.
No.
I'm pretty sure hopefully, unless they fire me or something, or who knows what will happen. These days, dude, we are living in very dark, unstable times.
Yeah.
I have never, the road we're on leads to perdition. I'm sorry.
Yep.
My daughter, my 11-year-old tells me, Daddy, don't be so negative. I can't help it. I try very hard to stay positive.
Yeah.
There's nothing. And whatever you do, don't turn the TV on. Anyway. Okay, I'm done. Sorry, brother. Take care.
Thanks, guys. Thank you, everyone. Cheers.
Peace out, Dave.
Thanks for that, Dave. Sal, I want to get right into a couple things with you here. In this device here, this is a patent you put out in 2015, and let me just copy the patent number and post it in the chat so people can look.
This was a patent that the high energy electromagnetic field generator experiment, the HIMFIG, was modeled on. This was the patent that was modeled on.
In this patent right here, it talks about ceramic material exhibiting a strong piezoelectric effect and property. Is this possible what the Tic Tac skin is made out of, like a ceramic material that's piezoelectric? Could this be a real thing?
This is complete speculation.
Yeah.
But just remember of how the Tic Tac was described. Do you remember those 4 protrusions on its bottom side that looked extremely similar to certain microwave antennas? Do you think, between you and I, do you think the Ebens would do crap like that? Or would it be more like the sports model Bob Lazar described, that basically talks to the SuperForce 3D printing this thing, this object, whatever it is that flies around out of space-time itself? 3D printing out of space-time itself. This is the kind of technologies they have. Do you think that's theirs or ours? Come on, guys. Come on. The truth.
Who do you believe to be theirs? Because was it on Tim Ventura or on Ashton Forbes' interview? You were mentioning below the sea possibly for the Tic Tac.
Transmedium, sure. Why not? I mean, if this thing has the ability to basically fool around with the gravitational field, do you think it would matter when it goes inside the water? Dude, think of it this way. What's spontaneous? Okay, Dave the physicist. I'm gonna call you Dave the physicist because if I say brother, we're all brothers, and you're gonna be who? So I'm gonna say Dave the physicist. Think of this. Is it true that spontaneous symmetry breaking is the same or almost the same as an abrupt phase transition, which is basically an abrupt change of state?
Yeah, you can look at spontaneous symmetry breaking as a phase transition of the quantum vacuum itself. But okay, keep going.
Okay, then what I'm saying is, and I'm not going to give the in-between steps. There's no need for that. Trust me. And I can't because of my disclaimer, all that crap that went ahead of it. Think of what you weigh. But basically that enables transmedium. Boom. Can it go through solid matter? And Ashton asked me that. And I choose not to answer that. But you guys are smart enough to figure it out. Can it go through solid matter under certain conditions?
Well, that was another, your 2017 patent concluded with a statement saying that the gravitons don't interact with spin 1/2 particles, but if you study Dirac electrons in curved spacetime, they're coupled to the frame field, and the frame field is basically a square root of the metric. So I don't know about the whole flying through matter part at that point. I don't know, worth mentioning.
Also, much how should I say, much simpler than that, because I choose very simple math. If you've noticed all my works, as a matter of fact, there was a podcast that's no longer on, but they were pretty funny guys. Like I used to watch it. Eigen Bros, remember Eigen Bros? Those two physicists. One of the things they complain about, like when they discussed the plasma compression fusion device, they said that my mathematics was too simple to be correct. Anyway, look, the bottom line is think the broil. Think the electron wavelength, and go further. That's all I'm saying. Simple, minimalistic mathematics that can point to very advanced, or what we consider advanced. Because remember, we're still apes playing with rocks, as Anastasia from Demystify Psi at one point said that we're still apes playing with rocks, brother. We bang it around and think we've discovered the quantum vacuum oscillation.
Sal, it might also be worth noting your heme FG, your HemeFig experiment, HemeFig, that there was an inventor out there who may have done something extremely similar, whereby he was putting very high separated charges on spinning disks and applied an ultrasound to it and was able to generate lift from this thing. It and he was doing it at the exact same time. He developed it from 2010 to 2018. And I think he finally got successful lift around 2016, right around the same exact time that you were doing your experiments. I just love the synchronicity of that.
A lot of people question this. Dude, I swear to you, right here, Jeremy, first, another first, I swear to you, these were my ideas. I didn't have anything to do with reversal, blah, blah. I'm not going to say it because, the algorithm will cut us off. But you know what I'm saying.
That's a good question, because that was one of my first questions.
Which means it talks to a super intelligence. Brother, listen to me. There is something that basically is trying to change these people's narrative. Do you think evil should triumph, or do you think good should lead the way?
Good, light, and love always.
Thank you, brothers.
Well, good always operates in the lightness, and evil always operates in the shadows. So we choose to operate out in the light and keep everything open source for that reason.
That's the way OpenAI started. See what Elon has to say about it. That's why he's so pissed at what happened. And I tell you right off the bat, if Ilya Sutskever would have gone with Elon, it'd be a whole different ball game. But he went with Sam. And I'm not putting Sam down. I think he's a genius. But Sutskever is the real genius over here. But this whole idea of large language models, eventually we got to talk about the triarchy of sentience. I think it has to do with AGI. This whole idea of putting a test based on computational power on, say, being trained on textbook data, not the crap that you see in the internet, but actual manual physics, manual experimental data, theory, whatnot, based on that. And if the AI agent, based on certain prompt engineering, that's very important too. So based on certain prompt engineering parameters, if the AI agent is able to create or generate an original concept, we got it, gentlemen. AGI is feasible. I think that's the test. I call it the triarchy of sentience.
Can I just?
Here's Elon's recent post on Twitter just to see what he feels about AI.
Whoa.
We'll see about that.
Grant.
Can I just add on one more thing to what I was saying? So in your Hemfig experiment, you were doing a wide range of frequencies for the ultrasound. And I was doing some calculations with a MATLAB calculator before this. At the lower frequencies that you were doing, the Lamb waves, the material waves going through it, you start getting into negative group velocities or zero group velocities for those waves, which does all sorts of...
the charge, the surface charge density was extremely small. That's why this thing, and still with 10 to the minus 8 coulombs, they still notice two anomalies that are not talked about. It's as if this thing, never took place. And so, you can't look. The way they dismiss my work by saying the Pais effect could not be observed, they could have been a lot kinder about it. And basically said, look, we used 10 to the minus 8 coulombs. The experiment said use 1 coulomb, at least 1 coulomb. Hence, we couldn't see anything or something of that nature. Not make this general statement, the Pais effect could not. So it gives ammunition to these naysayers and these, Jeremy, you and I know who they really are. We won't say it because we don't want to get, demonetized and shut down, fired and all that crap. But you and I know who these people represent. Do you think they represent good or evil?
Open-mindedness and intelligence.
So if I can just finish this question though. Yeah. So what I was trying to ask was, did you see a linear relationship or did you see like some weird like dips in there? Because if you were at certain specific low kilohertz frequencies, you get these negative group velocities, but you were going all the way up into the hundreds of kilohertz where this stuff all goes away. So what I was wondering is, remember how linear?
You got to remember that we took it to 100,000 RPM. So what, like 10 to the 4 radians per second. Think of, rapid acceleration transients. Again, this is all about engineering the Prigogine effect. Far from equilibrium excursions, while having an energy flux through the system, while the system is highly nonlinear in nature.
Were you seeing
totally non-equilibrium phenomenon?
Were you seeing most of these effects on the surface? In a lot of my experiments, especially when I have a high velocity across, I'm seeing them in the evanescent wave at the surface charges as they're being oscillated. Just wondering if you were wondering if this is a bulk material effect that actually happened mainly inside the bulk mass, or if it was right at the surface.
The heavy side equations. Let's call them the heavy side Maxwell equations from now on. So it's easier for me not to say the heavy side version of So the heavy side Maxwell equations, those 4 with 4 anodes, talk to a surface charge density. So this is really a surface effect. And why, Jeremiah? You will know the answer. Because this is a boundary effect. We're talking about boundaries. Again, what do boundaries represent? They represent changes of state.
Right. Changing the refractive index around an object changes the entire way that object interacts with the external environment.
Boom.
So, so that, and there it is. That's why you can do it with low energy, because you don't need to change all the matter inside of something. All you need to do is change the way that the matter in your
and that's why it makes me mad. That's why it makes me mad that Dr. Safadi had to put my work down all the time and agree with Eric W. and all that stuff instead of just being a nice guy, and playing it nice, because it makes me say certain things I don't want to say, because I think Safadi is very intelligent.
He is intelligent, and I later found that
he's a smart man. But I wish he was more like Lenny Susskind. Then, anyway, yeah.
If I may, I just gotta poke at Sarfati a little bit because it's funny. I found that there are 2 ways of being called a schmuck by Sarfati. there's the angry schmuck, and then there's the when he calls you a schmuck with a smile on his face. So if Sarfati's looking at you and he says you're just a schmuck and he's smiling, okay, that's a compliment. Thing, yeah. I mean, that's as good as you're gonna get. But he's really saying his praises to you, and that's what you get. So.
That reminds me of a cut. Yeah. No, you're right.
That's what you're gonna get out of him.
I have a feeling he's a really nice guy. Once you get to know him, I just have a feeling. But I think
he is a nice guy, man. He's a big time joke.
Through hell too. I think they treated him also with, because of the certain things he was involved with and certain projects he worked on. I think they treated him, they have a way to use you, abuse you, and then discard you, brothers. If that's good, then maybe, just maybe, evil is the new good.
Sal, anyway. If you had the opportunity to do the heme pig experiment again with all the funding and all the resources, would you do it?
Oh my God, yes, but I wouldn't use solids. I'm not gonna go there. Yeah, I already thought it. I know, and I know, dudes. I want certain members of you guys on this team. If it ever happens, it won't happen. The fact that it's not happening. Okay, for the members of the audience and all those nice IC members over there, Jeremiah, they're lurking over there,
Oh, yeah, I see them too.
Why not, I remember the one on Ashton Forbes. There was one guy anyway. There was a thing from The Ring, the movie. But listen, the whole idea is this. The fact that they haven't contacted me, that nobody has reached out with all these ideas, everything that's been said, and not at least giving me a CRADA. Yeah, you know what a CRADA is.
Yeah, they might be afraid that you're going to actually, solve it a little too publicly.
But what does that really mean? I mean, let's think here logically. If you come up with these kind of ideas and they don't even give you a possibility to work on them, what does that mean, gentlemen? Dave, the physicist, I'm not going to lay it on you because, you work for certain people, will link to certain people. Jeremy, I'm going to lay it on you, brother, because you say it exactly how it is. What does that mean, Jeremy?
I find a lot of, times, like they said, they will denounce it publicly, but they're working on it privately. They did that to Thomas Townsend Brown, famously, one of the first ones. It's been done to numerous people. So usually, you got to look for people that have a history of publishing lots of stuff and then go silent too, because that tends to suggest that maybe they've gone dark or are no longer able to talk about their work.
Well, sometimes they attack you, they ostracize you. Crackpot, the Bing AI.
But yeah, they call you they go and edit your Wikipedia page and call you a pseudoscientist.
October 18th. October 18th. If you look in the Wayback Machine, October 18th is when they added pseudoscience. And you know what that means. That's like
right? Before they gave you patents, then they gave you pseudoscience.
I guarantee that within 5 years from now, I won't have a Wikipedia page. Right here, I said as a first on yours, they will get rid of my Wikipedia page. You won't be able to find any of my papers. How much you want to bet on this?
I think you're too big to delete, but you're not too big to dis and try and take apart. So there may be misinformation, but I don't think they can get rid of you.
What we're dealing with here, I believe what we're dealing with here is something that is far, far older than all of us put together, all of our grandfathers, grandparents. We're dealing with a war between the children of the light and the children of darkness. And I'm bringing it down philosophically. This is what we're dealing with. This is epoch making. There's something extreme going on. And I'm not just saying that, oh my goodness, he's gone off the deep end. No, think of what's happening, certain things in history that have happened, what it points to. Think.
I totally agree with what you're saying right now, and I understand exactly where you're coming from. I've seen it happen again and again and again throughout history. All of my childhood heroes, the great inventors and the backyard discoverers, the self-taught geniuses that were making major breakthroughs, all of them were attacked in the same way. Some of them were killed over it. If nothing else, people like Hal had taken their stuff and started working on it.
I would never suicide myself.
It's publicly said right there. I mean, if something happens to you, it wasn't you.
Every chance I get, you know, the other person that had to do that, Andrew Tate. Dude, what they did to that dude back in Romania. Oh, by the way, I was born in Romania. So
you're Romanian apple pie, correct?
Yeah, that's right. American apple pie made in Romania, baby. Woo-hoo! With a little, a little spice there, maybe a little I wouldn't call it vodka because that's the right. It's called Slibovica. It's like a tsuika. It's a very, 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 very strong plum brandy. Woo, dude, that's all you need. You don't need NyQuil. You don't need to do anything. You know, when you have a major cold, you drink one of those. You boil it first. You drink a whoo.
I think that let's.
Sal, I have a question.
Let's get back to the physics if we can.
How strong of a magnetic field were you able to create with back in the day?
Like nothing compared to what you really need. You know what the Heaviside Maxwell equation speaks to. If you know that the Pais effect that comes out of them, it speaks to it's possible. So in order to do it, and I said something wrong on Ashton Forbes, and I like to correct it now. I said vacuum decay. As Dave, the physicist, tell you that'd be a bad day in heaven. So no, we're not talking about vacuum decay. We're talking vacuum breakdown. So this is like you cut the skin, you cut the fabric of space-time. This thing can recongeal itself once you remove the energy density that's involved. Yeah.
Can I
vacuum decay? It'd be like that's a bad day in heaven. Because that shit goes at the speed of light, and it just takes everything out. It's like the superintelligence reinventing itself. Like, forget about it.
I've been really wanting to ask you this question, Sal, for a while now. It's been one of the big things that I was taught that I've been pursuing as an end goal, and it's trying to reach a state in a non-visible cold plasma with a very high amount of surface charge. And what we're doing is applying two things at once. So first off, we're applying pulse width vibration at a very, very fast rise time. So that causes physical oscillation of the charged particles.
Are you doing transients?
Extremely high speed transients. And we're passing them through at the same exact time, the peak of a twisted magnetic field that actually follows in a strong inward curved geometry of a quadrifilar coil. And so we found that if you increase the angle of the wires, what you end up with is, instead of more of a distributed torus type of shape, you end up more of a beam shape that's very focused. And we're sending that through a pair of activated plates that are very closely spaced, just wide enough apart to get a laser beam in there and try to pump out the positrons that we're trying to generate. So by effectively putting the extra stress on the vacuum, we're trying to separate out the positron-electron pairs, rectify them so that when we pull them out of the space comes in to heal itself, rushes back in, creating a negative energy zone as it will be conventionally thought of. But really, it's you're taking the space apart, and you're taking one side of it, the electrons, pumping them into circuit, leaving the positrons to fly around the outside, recombining them at the back end, at which point they become again part of that space-time, and it expands, creating a pressure, or this would be Tesla's refraction and expansion of the aether. I know that people don't like aether, but I love the first aether because it is, So I'm wondering, what do you think about just reaching these energy levels by simply having extremely high charge density and high vibration?
Yeah. Keep on going, brother. Keep on going.
This is awesome.
But please, for my sake, don't publish these results. We are not here to enlighten and educate the enemy. You understand? So be very careful how much information you put out there and how you put it. Because you remember, Jeremy, you even had an episode. I remember on Kurt's podcast, I mentioned the secret sauce, and you were like, come on, what is this crap? We are not here to enlighten and educate the enemy. We're here to exchange ideas, but keep it superficial and keep it to the point that the enemy cannot get ideas out of. And yet we can still have a vibrant discussion. You understand what I'm saying?
Yes.
All right.
Okay. Well, I just want to put things. I mean, that's why I'm not bringing up anything that's personal research or anything that's not already.
Yeah,
out
whatever you do, don't show numbers, don't show ranges of frequency, don't show surface charges, nothing of the nature. Talk general stuff.
Yeah, general stuff. Generally speaking, I got a couple ideas for some things. I mean, what Jeremiah was talking about of putting something into a really tiny slit. This is an idea that came from Hal Putoff was doing a presentation a couple years back, and he
showed dude, man. By the way, Dr. Putoff, brother, I have no idea why EWD would so rapidly go against me, because he used to work for Dr. Putoff, and I know Dr. Putoff and I have a good. I mean, as far as I'm concerned, we have a good relationship. I think extremely highly of him, and I don't think he thinks I'm a crackpot. I'm pretty sure he doesn't. So it's very strange.
Anyway, and they've got enough people that have called them crackpots too. It all comes with the territory.
Yeah, it's so freaking unfair. You know that physical review paper in which he basically says, you know, on vacuum polarization, the whole idea of anyway, you know what I'm talking about. The inertial mass being okay.
I won't tell anyone that the secret sauce.
That paper should win him a freaking Nobel Prize, and yet because he was, you know, dealt with the remote viewing and stuff that's looked up. Dude, man, what's going on here, man? I mean, it drives you. If you didn't have other things in your life, if you didn't have you know what I'm saying? It would drive you mad. Absolute. Why must people behave in that fashion? Is it only me? Am I too sensitive?
Yeah, you got to like put yourself in I don't know. Lately, I've been just not responding to that kind of stuff. I just like, look, we're like a step above a lot of these people that are still just trying to learn this stuff and haven't figured it out. So,
but it still gets you. There are times you can't tell me that.
You have to level out. You can't let it emotionally trigger you, because half of it now is just AI bots, right? They try to trigger and emotionally drain everyone.
What's your actual name? Because I call you crypto analyst. I remember
Bernie. Thank you, Sal. Bernie. So my name is Bernie, so I go by Bernie.
Listen, brother Bernie. Brother Bernie, that doesn't effing excuse them. Period.
Yeah.
Well, I'm saying half of them aren't even people. It's just attack bots that the evil dark make up. It's definitely not excusable.
Half of them are not even people. But that doesn't mean it makes them anyway. Remember I talked about the gin? Okay, let me not go off the deep end, because then they'll think I'm a real crackpot. Okay, go ahead.
Hal put out this paper on one of his demonstrations where he talked about, you know, a metal mirror, a mirror with a dielectric filling in between, like a window in between, and basically it's a cavity where you can bounce light and focus light inside. And you know, I try to think of you have this Schwinger limit that we're trying to break, right? That's the whole idea behind this.
It's on the order of 10 to the 33 watts per meter square, or on the order of 10 to the 25 joules per meter cube. So we're talking about huge, heavy numbers here.
But just to kind of clarify and add to your point, what you just said there, these numbers are, you know, per large unit volume. We don't need a meter cube, do we? How much actual area do we need over the surface of a craft?
That's the thing.
Plate this, right? Just one plate.
Equation. It's energy per unit volume.
That's key. Sometimes you don't need high test sections. You don't need big sizes. You see what I'm saying? There are ways. Remember, it's called surface charge density, right? On the bottom area, for a reason, right? Okay.
If you want this number, you got to get this number to go to the 10 to the 18th. So you want it to go really high. So you have an equation of energy divided by volume. So there's two ways to do this. One is to make that volume go super small, right? Supercavitate the volume. The other option is to use the energy, and remember that energy is a waveform, and that we can concentrate the energy in waveform to try to blast, you know, space-time with more energy than it can take. And this relates back to, you know, something in nature that I know that concentrates waveform energy would be a bullwhip, right? If you take a bullwhip,
right, at almost a point in a certain locality, this thing releases its entire energy. Ain't that something? Yeah.
Yes. So it concentrates, and right at the end of the bullwhip is when it releases all that energy. And I thought this is very metaphoric, because if you're a slave owner on a plantation, what do you use to keep your slaves in line? A bullwhip. Yeah. So if we're going to try to free ourselves from the plantation, this might be the way to do it. It was an amazing. I thought about this. It's kind of like wow, this is the weapon.
You are a philosopher at heart, sir. I salute you. You are a philosopher at heart. That's another thing, and I'm pretty sure Dave, the physicist, I'm not sure if he'll agree with me on camera, but I think off camera he would, that physics and philosophy must once again be married to each other. That divorce would have never been allowed.
So the quantum mechanical Hilbert space kind of analog of a bullwhip is when we take the Fourier series and we break it down and create super high rise times. So this is the illustration of the how the Fourier series produces kind of a bullwhip effect to make this really incredibly fast rise time, and that might be the key to pumping enough energy into the quantum vacuum to break the Swinger limit.
Isn't
Just
it
my
awesome,
theory.
though? The Fourier series, isn't it beautiful, man? The whole idea that any polynomial, any mathematical function can be described as sines and cosines, hence vibrations, waves.
This was a video by a guy named Smarter Every Day.
Yeah.
This is just visualizing how the Fourier series works in real time with the idea of this whip, and that the different aspects of the different terms in the Fourier series being extension points along the whip. It's just, it helps really kind of bring it into our perspective.
If it's interesting to mention, experimentally, we've actually seen this kind of phenomena happen at the surface of a luminescent or illuminated surface plasma charge on metals, specifically silver and aluminum. We've seen it most, but there will be these sudden events where a very even symmetrical distribution of surface flow discharge, dielectric Fourier discharge style, there will be a sudden flash, a really, really bright event. And when you look at it under a microscope, you'll see that it actually ate away into the metal and completely blasted it apart, even though you only got, say, a few hundred volts at just a few milliamps flowing across that junction. Nowhere near enough. And the spacing between the plates, there's not anywhere close to the capacitance required. In fact, it's like 5 orders of magnitude too small to supply the energy to cause one of these surface deformation effects or one of these cavitation effects at the surface charges, but it doesn't stop them from happening. They seem to spontaneously self-generate.
Jeremiah, let me interrupt you for just 1 second, brother. On the Ashton Forbes interview, somebody asked about EVOs. What's your take on EVOs? Ken Shoulders.
I think they're a critical part. I've studied and read Ken Shoulders.
I feel like crap. Anyway, go
I've
ahead.
studied and read Ken Shoulders. My view on EVOs is they're a direct way to access extremely high magnetic field and extremely high energy density levels in a self-assembling manner. The great part about an exotic vacuum object is that you don't have to make it. You just have to provide the conditions for it to make itself, which means we don't need ultra advanced equipment or incredibly complicated AI level equations in order to allow these effects naturally to occur on their own. And we've done that and done a lot of experiments using exotic vacuum objects, following the work of Ken Shoulders and Morey and a variety of others. So I think it's huge.
If there's one thing I can add on to that, I shared a talk in the private chat here. There was a postdoc that had a good talk, Daniel Brandenburg, and he demonstrated how sonoluminescent cavitating bubbles in water, at the minimal point of cavitation, they can generate potentially up to 10 to the 15 Tesla magnetar level magnetic fields.
Any relation to John Brandenburg?
I don't know yet. I don't think so.
I'll ask him next week. Well, if I'm allowed for that one, who knows? Yeah. After this one, I think I've said too much. Go ahead.
It's worth observing though how ball lightning, EVOs, cavitating bubbles, all of these spherical collapsing or self-sustaining objects all seem to have this common trait of this soliton wave structure inside them that's maintaining them, and that as that collapses and the Q rises, and you get just this condensation of energy in a localized
energy got to go somewhere. I mean, thank God for energy conservation and still keep it within our side of the matrix. Because if God forbid there was anyway, I'm not gonna go on.
Did any of your
dimensions. Hey, what do you guys think of? Do you remember? Okay, I send you this slide presentation that I had on the AIAA paper, the room temperature superconducting on the Hawk, the hybrid aerospace undersea craft. That one. There are a bunch of slides. Look carefully at slide 4 to slide 9. I think they're very important. Just look. Dave Mathis thought so too. You know who Dave was, but it is. But anyway, look very careful at slides 4 to slides 9. Okay, it talks about macroscopic quantum coherence, but at one point I talk about the possibility of solving the vacuum catastrophe. The 120 order magnitude discrepancy between QFT and GR by not going at the Planckian scale, but actually working with like a space cell that's like, I forget what the numbers were, but like on the order of 10 to the minus 4 meter or something. But what's weird is that particular length is I know. Look, the man is smart, so I'm going to mention it. Is something that Dr. Eric W. Davis talked about a macroscopic extra dimension of that order, like 10 to the minus 3 or 10 to the minus 4. Look into his work. It was one of the papers. Do you remember, Jeremy, I know we shouldn't give a plug to anyway, but there were certain papers that came out of DIA, one of them written by Eric W. Davis. Look carefully at the dimension of the macroscopic dimension of this extra dimension, and you'll see how it talks to that space cell. And it's interesting because that talks to what? Terahertz frequencies. I'll just stop there.
Do you mind going more into the Schwarzschild proton and Nassim Haramein's work and the relevance with your
dude, I even tried to reach out to Nassim because once I plugged that thing in and noticed, I mean, the whole idea, look, again, an engineering mind, Jeremiah, you guys know the guys that are like engineers at heart. I mean, so I immediately, when I saw that it goes for a Planck and also as well as the horizon scale, I said, what about everything in between? So why not try the proton? And when I saw that when you put in the mass of the proton, 10 to the minus 27 kilograms, it gives you a reference length on the order of 10 to the minus 54 meters. It doesn't take a freaking quantum physicist to realize that's the Schwarzschild radius, 2 big GM and divided by C squared. 10 to the minus 4. So in other words, it's super force that makes the proton act like a black hole. So this thing will never really decay if left to itself. That's why, they're saying that the decay time is extremely high. And Dave, the physicist, how high is it? It's very high, like 10 to the 34. I remember.
Well, I mean, we think the proton could be stable. There's grand unified theories that predict it to decay, but it seems to be stable.
So it's stable. There you go. It's stable because it's acting as a black hole because of the superforce. Boom. So what if other particles act the same way? Hence vortex dynamics. We're talking about going, from the 10 to the minus 15, at 10 to the minus 54, something. We're not talking about space-time singularities here. We're talking about quantum bounces, hence super bang. The idea that at a super density, we're seeing something that's analogous to the physics of a supernova. How does a supernova work? Once the fuel runs out, gravitation collapse, boom, to what? 10 to the minus 15 meters. So you talk about 1 femtometer. At that particular scale, what operates? The strong nuclear force, right? Okay, well, what happens? Core bounce. Boom, that thing explodes, right? and the density it talks to is like 10 to the minus, no, 10 to the 14, 10 to the 4th is huge, 10 to the 14 grams per centimeter cube. Well, I am arguing that at a super density of 10 to the 90 kilograms per centimeter cube, so 10 to the 96 kilograms per meter cube, something like that. My math could be off, but anyway, something like that, huge, you know, we're talking about big. That because of the 10 to the 44 newtons, so we're talking about the SuperForce acting at that 10 to the minus 35 meters at the Planck scale, it undergoes, boom, the Ashtekar bounce, the whole idea of a quantum bounce. That's what, so there are no space-time singularity. It never goes to zero. It goes to the Planck length. I'm just putting it out there. So we sound crazy, but what if I'm right? What if the SuperForce creates a super bang and eventually, because of the nature of the cosmos, according to Anthony Peratt, more than 99.9991%, we're talking about hydrogen plasma, correct? What if, because of the nature, for example, we have what? 100 billion neurons, right? Supposedly there are 100 billion galaxies that each have 100 billion stars. You see what I'm saying? It's almost like a neural network, man. We're talking about a possibility of a super intelligence. SuperForce, because of the super density, super bang, super intelligence. Boom, the triarchy of creation. There you go, Michio Kaku. That's that Michio God equation.
What do you...
I'm just trying to be jocular.
All right. No, it sounds very much like the Boltzmann brain ideas.
Yeah, I was just going to ask you, what do you think about Wolfram?
Oh, dude, this guy is so... I think he's so brilliant. I mean, I would, if I understood some of that math, dude, the truth is I don't have, for example, the mathematics knowledge of, for example, Jeremiah Pop, I think, is more like me, but maybe I'm wrong. Maybe your mathematical knowledge is as good as Michael Perron's, is as good as Dave's over there. I mean, Dave, the physicist math, oh my God, I tried to follow one time. I thought I was going to deliver. I'm not kidding you. Talk about pregnancy of mind, man. Oh, speaking of which, listen, I would love an MMA type where, you know, a couple of us, you know, that supposedly do not operate in the mainstream, a couple of us go in a quote unquote, and then, you know, a cage of some sort, but the whole thing is televised, and we go with some real credible physicists out there. You know, we talk about Seth Lloyd, we talk about Tegmark, David Gross, why not Stefan Alexander, Brian Keith? You know what I mean? Like
Tyson on there.
I love the idea of a physics battle, MMA style. Heck yeah.
Don't forget Maldacena. He's highly mathematical. That ADS equals CFT, he forgets that we live in a de Sitter space, according to Eric Valinde and all. Anyway, Eric Valinde too. I would like to see how he behaves so close to Maldacena. But anyway, you know, we might get a buddy in there. But the whole idea is an MMA type, like combat of the minds. It'd be so cool, man. Dude, it might
I love that idea.
You know what I'm saying?
Mixed mental arts.
I'll play the Joe Rogan and be the referee announcer.
It might be the biggest show in the history of shows. I guarantee that thing would attract a lot of people. Because there are a lot of Joe the plumbers out there interested in physics.
Well, they had Crossfire for politics, so we should have like a Crossfire for.
And they don't have his knowledge. They're not allowed to publish in these great journals that have great impact factors. You see what I'm saying?
I know you got your.
Sorry about that. I'm going off the deep end. Yeah.
So, did you the 3-pager you made? This is public now, I suppose, or?
It's a preprint. Yeah, I can publish it. I can publish it. Nobody.
So, section 4. I was curious what you meant. I was curious what you meant by applying equation 1 to equation 2 in section 4. You had your x on the order of y, y on the order of z.
Equation 2 is the Schrodinger equation.
Sure.
Now, Dave, the physicist, can attest to the once you take the Schrodinger equation. I'm not talking about Dirac equation. the Dirac notation here, because, oh my God, that gives me a headache. I'm talking about simple stuff. You take Schrodinger's equation, okay, which is really a linear equation. You take that, you combine it with E equal M, whatever, M dot C square plus P square C square. You know what I'm saying? Like the whole Pythagorean thing, E square. You know what I'm saying? I'm talking about special relativity. You combine special relativity with the Schrodinger equation, you get the Dirac equation. So I'm saying whatever applies to the Schrodinger equation because of the linearity of the thing will apply to the Dirac equation. And when you actually write the Dirac equation out, you see the terms resemble that of the Schrodinger equation with the terms added in for special relativity, for the relativity.
So I'm a little,
but it's a little different.
Confused about what specifically you're
No,
doing.
let me explain. Let me explain. If you look at the equivalence of the terms, hey, we have a really young physicist in here. Hey, brother. Is it a brother or sister? But it sounds anyway.
Yeah, that's my daughter.
Dude, they start young, brother. Hey, oh man, I tell you, she's gonna be brilliant, brother. Anyway, I'm trying really hard to push my daughter toward math and physics, and I'm trying a little too hard, and I think she like hates it because dude, you should never force a person to do anything, especially the ones you love. But anyway,
you have to trick them in through video games and stuff, like educational ones.
Dude,
almost.
STEM kits. There are so many good ways for a kid to get their hands on stuff. When the mind is young and it's learning, you've got to give them a chance to play with it. They've got to play.
Michael, I promise we'll return to your question. I promise. But go ahead, Jeremiah, because that's important. Again, philosophy. Hey, brother. What's the flavor, by the way?
Well, it was lemon cola. It tasted like soda, but I've been putting this just basic mint flavor in there. So mint with nothing but glycerin. It burns nice and clean. It's just a plain old cheap nicotine delivery system, but it works pretty well.
Hey, as long as it gives you a little boost of energy. Yeah. But anyway, go on with that, because philosophy, again,
the philosophy of the young mind, right? When a kid is learning, we can't just try to dump tons of ideas on them and convince them that they're important. This would be like, word questions in class. We're told that we have to know these things, but never told why we'll need them or when we'll use them. We'll give a kid a kit. Let them put their hands on something easy to assemble. And all of a sudden, science is no longer a task. Physics is no longer a career. Now it's play. It's just play. And so their minds naturally learn because you've let them play. Yes. And there are plenty of kits out there, STEM program kits specifically for this at many, varying age levels and talent levels for just getting into it. But we've got to let the kids play. Otherwise, they're not going to have any reason to want this.
Exactly. That's good child psychology, bro. But in a way, you can call it philosophy of the mind. I mean, that's what psychology really is. It's a type of philosophy. Jung was Freud's student, correct? I think so. So truly, psychology it has its roots in philosophy. Am I off?
Yeah, there's some really weird roots too, because like Freud wrote like pretty much the whole background of psychology, and he is a complete psycho weirdo who assumed all people think and process thoughts like he does.
Yeah, I studied Carl Jung, so.
Young was a student, though. They diverged, but
they were the Aristotle and Socrates of psychology, because they had such similar starts, but then such radical separations.
Yeah, let's not forget that before the term electrical engineer ever existed in the twinkling of anyone's eye, electrical engineers were called philosophers. They were the same thing, and so those good old boys that play with the influence machines, hand cranked and otherwise, they were philosophers. They weren't electricians or electrical engineers.
You know what popped to my mind? Eric Dollard. Dude, again, Joe the Plumber, someone that doesn't have the so-called quote-unquote what they interpret as the right pedigree. But dude, you listen to the ideas of this man and what he has to say. Especially there's one guy out there, man, I would have never known of him. And I started to study about Charles Proteus Steinmetz. Holy. I wish I can say the word, but anyway, I won't. You know what I'm saying? Wow, dude, Steinmetz. You remember how he was structured, but what a giant! Isn't that interesting? How
I'm going to pull up one of Steinmetz's works here, actually, see if I can get this on screen. A really
remember
good diagram.
What he has to say about transients, waves, oscillations. Remember? That's important, brothers. Look carefully what Steinmetz has to say about
that's actually out of the book that I wanted to pull this diagram from. You have the equipotential field that shows up. It's not the electric field. It's not the magnetic field. It's the equipotential field, which means this is the point along the intersection of the magnetic and the electric that is equal in stress energy density for that local space, acknowledging a more complicated interaction of electromagnetism with gravity.
Is that counter space?
That's what Dollard would call counter space, or where it happens at least.
Right. And Michael,
Groovy.
I didn't forget about you. Brother, look carefully at the equivalent. So I'm sorry to interrupt. We'll go back to this because I think Eric Dollard should be looked at carefully. And also all the stuff, the way he's been able to bridge all these people that for some unknown reason, history has forgotten. Anyway, we'll go back because I have to. Steinmetz was a genius, a total freaking brilliant genius. You know, there are pictures of him close to Einstein. You think Einstein hanged around who loses? But anyway, let's go. Let's go back. Right. So basically, look at the Schrodinger equation. You know, you have that IH bar, the psi dt, all that stuff. You know, I can do it, but you know, I'm not as mathematically apt as the one over there in the corner. You smart. His mathematics freaking, oh my God, it gave me a headache just looking through one of his slides. Anyway, I mean it, Dave, just one. Oh, okay. So look carefully at that Schrodinger equation. You know how if you just do like a simple, you can call it like a scaling, but more of a dimensional analysis, but don't replace it with like meter per second square, all that crap. Just think of it as, how should I say, like parameters. Maybe it should be called parametric analysis rather. But anyway, so if you do a little replacement, you can see that when you take, so all those terms are equivalent. In other words, from a physical perspective, they all count. That's what I mean by equivalent. I don't know if I'm right. Using the right terminology. I mean, from a mathematical standpoint, I could be like talking kindergarten language, but I'm trying to get to the physics of it, the Dollard way. Right. Okay. So all those terms are equivalent. Okay. So when you take if you take like one of the term and you sort of equate it or say it's on the same order with another one of those parameters, E equal h nu comes out. Boom, Planck's equation. You do another one, the lambda equal h bar divided by mv, right? De Broglie comes out. And then when you do the one, I think term 3 and term 2, when you equate them, you know, from a point of view of physical equivalence, I don't know what to call it, order of man, whatever you would choose to call it, order of importance. You can call it order of importance. When you do it like that, what comes out is the superforce, right out of
okay, I get you now. I get you. So x, when the total amount of energy is proportional to mc squared, you have particle-like behavior. When your total amount of proportional, I should say correctly. When most of your energy is in the mc squared term, then it behaves like a particle. When most of your energy is in the p squared term, then it behaves mostly like a wave. And then when the
d sub
mc
x,
squared and pc squared are similar in
remember
magnitude.
Remember the way Penrose refers to that? It's like a rest energy of the, right? But the rest energy talks to what? To what's there, to an energy gradient. That's how you get the superforce, by considering an energy gradient at the Planck scale, and boom, the superforce comes out.
So, and then the notation here is just a little small gripe, but the notation's just slightly sloppy. It's you have V over LR, which
I'm a sloppy guy.
I assume
maybe
you're
what I
talking about the Planck.
One of you guys, the smart guys over here, that physics pedigree, Dave. Maybe we should cooperate. write a paper based on this, and then we can put it to archive, because I know that you got the right sponsor. You know,
so
I can. Do you know I can't even get a sponsor to put my paper on archive? That's how bad it is.
I mean, everyone. It's like that for everyone. I mean, you know, like you got to understand the culture of what's happening. I mean, that's very common. So it's not like you're getting singled out. You know, you're getting treated just like everyone else.
Yeah, it's rough right now.
I mean,
it's very
there's huge resistance to change always, right? It's that human mentality that you have to defend like the current paradigm, and that anything outside of it, right?
Archive.
And if you went
human impedance,
university that runs archive. I mean,
so anyway, so when LR is of the Planck length, then you effectively you get a differential from that because it's the smallest size you can have.
But you're taking Schrodinger's equation, which has nothing to do
in the Schrodinger equation. What is the Schrodinger equation? It's really the coupling of Planck's energy with de Broglie's idea of the, you know, electron wave function, whatever you want to call it. And the superforce is in there because that potential of that particle is in there. That's why the superforce is so freaking important.
No, Schrodinger's equation. Schrodinger's equation is non-relativistic and it has no gravity. The superforce involves only G and C. So you're just putting in the Planck length and then just playing dimensional analysis to get whatever you want out. I mean, it's not. That's why.
But
that's
I'm not.
why people won't accept this in a journal.
But I'm not playing with it. I'm not playing with it, Dave. I'm not playing.
I'm
with
just
it.
saying that the potential energy, the superforce is not in the potential energy of Schrodinger equation. It's just a fact. No, it's not there.
With anything. It's physicality.
I'm just saying that the potential energy in Schrodinger's equation has nothing to do with the Planck scale. It's simply.
But when you write it as an energy gradient at the Planck scale, all of a sudden the superforce comes out.
Right. If you plug in the Planck scale in the quantum mechanics, you can get the Planck scale to come out because you plugged it in, and that's why you're playing games.
Well, what he's kind of, I think, saying is that if you look at that potential
term, the superforce operates at the Planck scale.
Superforce.
Go ahead, Michael. I'm sorry to say, but the superforce operates at the Planck scale. That's why I put for that reference length the Planck scale, the GH divided by C cubed. Okay, but it's L squared. You know that L squared term. So it's just anyway.
You don't need the Schrodinger equation for your statements. I mean, you're more interested in quantum field theory, as you're saying. It's all about gravity and quantum field theory. So I just thought that bringing in the Schrodinger equation was kind of.
I was just trying to show that you find it, just like you find E equal H nu in Schrodinger.
You find it, but other physicists won't find it. I'm just trying to articulate why.
You're saying that he's just recovering it because he plugged it in, right? Is that?
Yeah, I mean, he's essentially taking Schrodinger's equation and then trying to put in the Planck length.
But I'm not plugging it in. I'm not.
Well, I'm just saying Schrodinger's equation doesn't have G or the speed of light in it, so you have to do something.
It doesn't matter.
I mean, it does matter. I mean, it's the equation.
No. Think what? Okay. Think physically. Don't think mathematically. I know you're highly mathematical. Think physically now. Totally physically. That reference length, why am I plugging in the Planck length? Because I'm saying that the superforce acts at the Planck scale, hence at the Planck length. That's why I'm plugging in the Planck length.
But that has nothing to do with Schrodinger's equation.
But no.
And that's your starting point.
No, the superforce has no intuition as to why it's C to the 4 divided by G. It comes out of the Planck length being plugged in as a reference length. That's
so this B term we're talking about.
I thought you defined as the Planck force. I don't know what this thing is.
So the B term is a function, right? So are we plugging in V like as potential in units of potential energy in some sort of integrated form over that small volume or small length scale, or what's this equation saying really? Just trying to make sure I'm understanding.
One day I may be able to explain it better, but right now all I'm saying, look at the equivalence of terms. I'm saying call it an equivalence based on order of importance. So every one of the terms in Schrodinger's equation is equally important, okay? Based on that, when you write it down from a parameter point of view, make sure that the dimensions stick, okay? When you take term 1 equal term 2, something like E equal H nu comes out. when, or term 1 and term 3, okay? Something like E equal H nu comes out. The energy, you know, based on Planck's whatever constant with a vibration fluctuation. Then when you put in the reference length as lambda based on, say, like a wavelength, the Broyle stuff comes out. When you equate, you see what I'm saying? And then when you finally put in that reference length as Planck length, based on this equivalence of importance, whatnot, the superforce comes out. All I'm saying.
What are your units for V?
You didn't need Schrodinger's equation yet.
How are you treating
the superforce? Okay, if the superforce was purely classical, like it's shown in GR, it should not come out of Schrodinger's equation. That's my argument. But it does. Why? Because it's also microscopic. It's also quantum in nature. Even though it doesn't have the H bar. This was Abba Ashtakar's beef. On Kurtz, when Abba Ashtakar came on Kurt's TOE, you can see that episode. Google it and you'll see it. Kurt actually asked him, what do you think of the superforce? And he said, no, it's interesting, but it cannot be fundamental. Why? Because it doesn't have H bar in it. It's not quantum. Not true. That's what makes it so beautiful. That's what makes it so special. It's that thing, because it doesn't have H bar in it. But remember, the super density is C to the 5th power divided by about like big G square H bar. So the super density is the one that's quantum, that the super force operates on to create the super bang. You see, that's where the quantum aspect of it comes in. When I'm trying to say the super force acts everywhere, at every point in space-time, at the Planck scale. That's all I'm arguing for. Maybe one day.
But I'm just trying to understand the argument, though. So V over LR, you have length scale, and then
someone that has better mathematics to express what I'm trying to express there. But there's no way. You cannot convince me that out of Schrodinger's equation, when you do equivalence based on order of importance, first Planck's energy equation comes out, then de Broglie's lambda, the electron, whatever wavelength comes out, and then the superforce comes out. You can convince me that's what's the word I'm looking for? That's see, I'm lost for words at times. So come on, someone help me.
Memes here has a question.
What am I looking for? What's the word I'm looking for?
May I attempt to steal Dr. Pais's, Brother Pais's opinion here for a second? If Jeremy could share my screen for just a moment, just because seeing some visuals rather than like laying off all these different my screen down below. But basically saying all these words, G, big G over this. I'm a very visual person as well, so I'm a noob. So I just go to Wolfram Alpha. I type in Planck force, aka the super force. Okay, as we can see, we have our C4 over our big G, speed to the 4th by the Newton gravitational constant. It gives us these numbers right here, 10 to the 44 newtons there. All right, and then we take equation 1. We plug in. You can literally just on Wolfram Alpha, like just plug in just natural language these terms. Planck mass times c squared, so just carry it up to the 2nd divided by the Planck length there. We subtract out just mass of universe, so we have the universe mass, ordinary matter that we're trying to account for, times c squared, speed of light squared, divided by the radius of the observable universe as we know. And it is very interesting. It does come out to be very close to the magnitude, about 0.7 there, the Planck force, which is interesting because if we're going to try to account for perhaps some dark mass effect, whether that's a dark matter particle, a neutrino, a black hole, anion, whatever flavor it might be there, that is an interesting thing. So I believe that what Dr. Pais, the claim is, and part of this maybe is a bit of a mistranslation here, is very often if you're making a claim, I feel the way you wrote the paper, sir, is you're kind of saying it's evident there. And it might be. It might actually be the truth. I don't know that, but very often from when I've listened to Professor Wolfram in a lot of his lectures and live streams, he'll say, the claim is this. So let me try to restate this. So the claim is that there seems to be a relationship on the very large, utilizing the Superforce, the Planck force, because there does seem to be maybe some correlation there with what might be going on the very large.
But that's why I didn't use the equal term. I used that squiggly line meaning on the order of.
Right.
Boom.
Right. So
And
that's what's this.
Don't forget there could be that 8 pi in there that we don't really know. That 8 pi is essential, and I think it talks to a geometry. There's some geometry, there's some physics going on. That 8 pi should be looked into. That 8 pi maybe is in there. In which case,
wait, we're getting there. I'm sorry to cut you off, sir. But when you take, as you were saying earlier, 1 over the Planck force, you get all these crazy numbers here. But the one popped out. I'm like, the Einstein constant from the C4 convention. So I explored if there was perhaps a geometric representation of this. And I'm like, oh, that last number was a 9. That's an 8 followed by an 8. That looks like 1 over 8 pi. I mean, that's pretty neat there. So, I mean, there's cool stuff here. Do I know it's right? I don't know. I just feel like we should give a fair shake. And to be fair, if you are putting terms in here, I believe the claim that you're making that if you construct it, the Schrodinger equation in a particular way, you've made some observations. And again, it's very often the Schrodinger equation is what for like ground state of hydrogen or whatnot there. And we believe it works to the best of our knowledge. And then getting past there is very difficult.
It's a fundamental equation, but it shows reality, shows physical reality. All I'm asking is if Planck's energy comes out of it, if the Boyle's wavelength comes out of it, and the Superforce comes out at the Planck scale, that cannot be circumstantial evidence or whatever you want to call it. Hey, Jeremiah, come in and help me, brother, with a better word. Come on. I need a better word.
If it emerges under the right conditions naturally, then what we need to do is correct the math to match the experiment, plain and simple.
I need better explanation of the math. Mine is very rudimentary. I need, someone of their Dave type.
It's not a coincidence. It's no coincidence it puts it up.
Thank you. That's it. That's
well said.
Crypto alchemist. That's right, crypto alchemist. It's not a coincidence. That's what
Can I jump in here real quick?
Yes.
Sal, so one of the things about your paper and your theory that I think would just supercharge it is to find some sort of observation in existence that your model correctly predicts or even improves upon. So what I wanted to say was the squiggly somewhat equivalent to 0.770% of or whatever. If you can find that difference there that brings it 1-to-1 to whatever the cosmological observations are.
What are they doing now? They're doing James Webb crap. What if they find something that the radius of the observable universe is blah blah? Then that will tell you the exact mass that. You see what I'm saying? Then you'll see.
Or it'll help improve upon your model. See if you're close but not quite there, and then you look out at the observation, you're like, oh wait, I'm just like Einstein. I'm off by a factor of blah. I need to incorporate that into my thing.
Brother, whatever you do, please, man. Einstein was like right hand of God. Please don't compare me with that. I'm a guy just trying to be heard. Okay. So never compare me with a big man.
I'm saying the cosmological constant that he had to include in order to make it work. Yours might require a similar modifier.
Yeah, man, Dalit. We gotta come back to Eric Dalit. Another one that because of his pedigree is not being looked into. What the hell, bro? Is this what it's all about? You know what I'm saying? I mean, why not be given a chance?
That man is single-handedly keeping the legacy of RCA alive.
I would have not known crap about Steinmetz's work if it wasn't for Dalit. A lot of people would have been oblivious to a lot of things out there. And you got to look at Dalit's mathematics. This is what I love the man, because it's simple and it talks to great physics, great physical understanding. And this is what I'm talking about. You do not need complex, abstract, mathematical acrobatics to understand great physics. That's my argument. Unfortunately, a lot of people say that such complex mathematics is necessary to be considered as a great physicist. And I tell you, that's a bunch of gobbledygook. That's all.
Yeah, I mean, Faraday is an example, right? I mean, so you don't need mathematics to get the principles, but eventually you might need mathematics to solve some of the problems.
Down.
Yeah,
he never wrote one. Yeah.
Well, this is up. I just wanted to mention, like, where Eric Dollard really started with a lot of his major discoveries was with this specific book. You'll hear him talk about this book all the time. This is what your intro page looks like.
Yeah,
going through this book, it is loaded with a ton of diagrams. Let me just
and we
scroll
would
down
have,
into the meat and potatoes. So,
if it wasn't for Dollard, this book would have been lost.
No
a great
kidding.
book would have been lost if it wasn't for him.
Like curve charts, relationships between field forces.
Was unbelievable.
Yep. Yeah, it's unbelievable. So yeah, definitely. This book is free on archive.org. So I'm not going to drop a link here, but if anybody else wants to, that's fine. But yeah, this is free on archive. So grab it if you want to research this stuff. That's all.
That's the background that we use on the channel right there. Is that image, figure 9 right there.
The Steinmetz diagram.
Unbelievable, dude. Dude, man, there were a lot of them. Now that I think of it, Jeremy, you know, because you put a lot, dude, you've done a lot of research in this. How many people are we talking about that have been dismissed by the history of physics completely? As you know what I'm talking about. A lot, right?
There's a number. I mean,
sorry to interrupt. I just have
physics, but related fields too, like Nobel Prize in chemistry. I think in 2011 was Daniel Schechtman, and he was called a quasi-scientist for his discovery of quasi-crystals by the leading chemist in the world at the time, Linus Pauling. So there's been so many great discoveries that have been called pseudoscience, have been ridiculed and laughed off the map. So that's why
they have to come out of the fringe, right? It's got to be out of the box thinking for it to be a new groundbreaking or shifting idea, a new paradigm. It can't be, by definition, anything that's new paradigm can't be from the old paradigm, right? And I just wanted to state your background actually was created by me and Jeremiah and Paranoid American by AI. Jeremiah was entering in some extremely technical questions to the AI, and it generated this background that we're using, which is the same as Steinmetz diagram.
I think I was actually asking him about equal potential fields on that show, so yeah, it would have been.
So Steinmetz believed a lot in non-equilibrium phenomena. Look what he had toward the end of the little book. Man, I love these little books. I tell you, every one of my books that I have are little. I don't have anything big. Even, the biggest book I have on quantum theory is the one Dave knows. I bet you, Anthony Z, Quantum Theory in a Nutshell. Ain't that a beautiful book?
I didn't even hear about that book. Sounds like
a good conceptual book.
Understood, but anyway, yeah.
It's not very helpful for homework, but it's good to understand the quantum field theory.
Feynman's volume 3 in his lectures. I tried, but Z is a master. Really, he's able to. Anyway, and I'm not saying Feynman was. I mean, Feynman's again. If Einstein was on the right side, this dude was on the left side, so not bad. You can go a long way with such archangels. So yeah. Anyway. That's why it really pisses me off when people try to prove Einstein wrong. It rubs me the wrong way. And that's why I like that archive. It's the way it is. Because I'm sick and tired of hearing Einstein was wrong. Even Michio Kaku said it recently. Why Einstein was wrong. I want to say it, but I won't.
It's just memes, It's just a mimetic saying. Yeah, like everyone wants to be smarter than the smartest guy, like whatever. It catches people's interest. That's part of the problem with all this, is the Tower of Babel. People have their words that mean things, and they pigeonhole things because of that, and that creates a lot of problems.
Why try to bring the grades down? Why always try to bring? This is like, remember, Jeremy, remember that the crabs in a pot thing, one crab does, the other one's pulling down. Yeah, you know what I'm saying? It's like, what's going on here, man? Dude, if we must re-engineer something, we should re-engineer human nature, because it's human nature that's been responsible for all the crap we're dealing with today, maybe more. Anyway.
Well, unfortunately, the best of wisdom comes from successful adaptation to suffering, but that's sometimes how it is in life. What was I going to say, though? Yeah, I mean, to some extent, you don't necessarily need the mathematics to understand and be a great physicist, but you will need some level of mathematics to efficiently explain that math and physics to other people. And that's the important thing.
That's why I need a pedigreed physicist to help me rewrite this paper and to get and if he wants to publish his first order, because I know it matters, like in the field it matters, but I need someone like that, so I can co-publish with, because otherwise this idea will never be seen. That's the bottom line.
I think if you just focus, like the SuperForce paper has like 5 sections, and they're all, I mean, you claim that they're related, but to me they're almost independent sections, and I think it would make more sense to just focus on one topic and explore it in more detail. And like I was criticizing you for using the Schrodinger equation, but I originally looked at your SuperForce paper first, and I was just like, why is he not talking about 0-point energy? Why is he not like, it's about quantum field theory? But then I went back to your 2017 patent, you were talking about it with more detail there. So I think you're trying to make it so simple and not go into math, which might be good for kind of a lay audience, but it's just not really appropriate if your desire is to get a paper published in a journal, then you kind of have to speak to their language. And so I mean, I think that you could sort of reformulate that first idea that the means of destruction was talking about. That was in section 2, not section 4. So yeah, I mean, I did actually write up like 5 pages of notes on it. I mean, it's pretty critical of what you're saying, but I reformulated your
so maybe you and I
2.
should cooperate. Dave, the physicist, you and I should cooperate and get a paper out. Maybe try to put
I'm at least willing to share my ideas with you.
Listen, I wouldn't mind if you were a first author, not at all. I just want to get this idea out so it's looked at rather than considered garbage.
That sounds like a great team up, honestly. David has one of the brightest math brains I've ever seen.
Look, I've never cared who was first author, second author, third one. I'm sick and tired of that shit. I need these ideas out there. We need these ideas out there for others to take them and run with them and do greater things, so this civilization can progress, so we can break the shackles of Earth and be done with this rocket crap. It's 110-year-old technology. It's based on Newton's third law of motion, for goodness sake. When did Newton live? Freaking, what, 1600s? Please, man.
Oh, man, I know. Right there with you.
mean, liquid hydrogen, liquid oxygen. Sorry, I'm going off the deep end, but this really rubs me the wrong way. Nicholas Tsiolkovsky came up with the rocket equation, like late 1800s, like circa when Heaviside came up with his version of Maxwell's equations. We haven't progressed since. The only way to transport a craft through space-time is to throw. Oh, I want to say something.
Yeah, I know, man. That's literally why.
NASA and propels. Please, man, come on, Elon, you can do better.
That is literally why we started APEC.
You can do better.
The Alternative Propulsion Engineering Conference exists as a brainchild to solve the problem of having to fling crap out at really high speed off the back end of your ship. And so I think that we can do better, if we understand the concept of fields and forces and have any kind of clue whatsoever about how the universe works at the underlying level, then maybe we can stop throwing things at space to try and move ourselves forward and maybe do something a little smarter.
It seems to me that our physics is based on destruction. other than it should be based on creation. Maybe that's what the so-called new physics should be all about. Everything we've done is based on explosion, based on freaking. I mean, what's a rocket? It's a controlled explosion within a cylindrical chamber. For God's sake, that's what it is. And if God forbid you miscalculate the whole,
it's a ludicrously successful technology.
Obscenities to see exactly how I feel inside, but I won't, because it's driving.
Amen to that. I mean, like, even just the whole, it's kind of crazy. Like everyone here on Earth is like, oh, we need to build rockets to get off of Earth because that's how we're going to save our species. But like, if we actually could figure out how to live sustainably, and then people would be perfectly fine right here. We don't have to escape. Like if we run into space.
You cannot tell me. Sorry to interrupt, Michael. I promise you have the floor, but I gotta say this before I forget it. Remember, I'm much older than you. You know, I don't know how Jack does it, but awesome, man. At that age, to be able to, I think at that age, I'm lucky if I can, anyway, drink a cup of coffee the right way. But okay, I'm not gonna go there. I hope I make it. But anyway, look, the bottom line is this. We have to look toward new horizons. We have to look toward methods of creation rather than destruction. Oh, that's my cat. I got a cat, you know, one of those things. I think she's hungry, but that's okay. You know, sorry, baby. She gets a little bit sensitive. But anyway, Michael, you can go back to the whole thing I wanted to say is that our so-called new physics should be based on creation rather than destruction. That's all. Go ahead, Michael. I'm sorry.
Yeah, and all I was saying is, if you think about it, it's kind of absurd that everyone assumes, oh, we have to survive by getting into space, where it would actually probably be much more practical to simply figure out how to live here on Earth with the resources we already have. And I'm working on another project outside APEC, the Technocopia project. It's basically a self-replicating system that takes care of all of a person's basic needs. Like if you can just make that and have that be relatively innocuous with the waste that it produces, and perhaps have some advanced energy generation technology, you could easily, like one of the fundamental things on Earth right now is scarcity is used as a means to control people. But if you produce a post-scarcity society, that goes away too. So, yeah, I mean, you would be able to have a world with a lot less coercion and everything. And if everyone's building instead of fighting, that's just a much better world.
To jump on your thought, you don't think that Elon, among his team, I mean, this guy is a multi-billionaire. You don't think among his team of scientists, engineers, whatnot, nobody has talked to him about field propulsion and the possibility thereof?
Certainly, he probably has.
And why? And do you think he's dismissed it out of hand, or is he doing stuff in the black that we don't know about?
Probably the second.
Hopefully.
Well, one would hope.
I just wanted to riff a little bit more on means of destruction's calculation there and the modifier to your equation. So it looks like he was at 0.7 of the Planck force, right? Your thing comes out to roughly about 0.7 of. So for the modifier, if you multiplied it by the golden ratio, it's going to get you kind of closer. But if you multiply it by √2, you're going to get real close. The reason why I'm bringing these particular modifiers up is because you're looking at a scaling force, something that needs to follow the changes in scale. Well, anytime you have something that needs to follow changes in scale, you must invoke fractals, because fractals are the code the universe uses to say, I need something big and make it smaller, take something small, make it big. It uses a fractional dimension scaling relationship there, right? So what I want to say was I wouldn't be surprised if your particular model simply requires a scaling that just so happens to follow some divine freaking number out there, because God made the universe to have some particular code in it, like the Sierpinski triangle or the √2.
Ain't that some? Doesn't that talk to a super intelligence? But anyway, the whole idea of fractals, isn't it awesome that the ability, I mean, we're talking about a microscopic geometric pattern repeating at macroscopic levels. I mean, that's what fractals are all about.
Right, like a fractal is both indefinite and finite and infinite within itself, right? It's finite and infinite all within one set. It's a dimension of its own.
As above, so below.
It's freaking beautiful.
It's worth also,
baby. That's right.
It's also worth noting some of my most recent research. I take some of Ray Stanford, the ufologist from the 20th century. I take some of his data that he recorded, gravitational and magnetic changes associated with movements of UAPs, and I found some UFOs.
I can
stand UFOs. Sorry.
These are objects. They're physical effing objects. There you go. Unacknowledged effing objects.
1978, he takes all these recordings of it. They do a Fourier transform of it. They find the frequencies that happen to pop out of this. I've done a massive amount of calculations on this, and I am like greater than 90% certain they're utilizing combinations of the golden ratio to induce electromagnetic and gravitational changes, which, if you're dealing with these scaling problems of needing to take your electromagnetic force and fit it down into the gravitational force, you've got to have some kind of scaling correspondence there. It wouldn't be surprising if the golden ratio heterodyning that they're using in UFOs also happens to work with Pais effect.
That's good one, Jared. Good one. Good observation. Definitely. Very interesting, bro. Jeremy, the floor is yours, brother. You can direct it however you want. I'm here for the duration. However, until you guys get bored by me, I'm here. So
I've been told that the secret sauce.
I'm pretty sure that Dave, the physicist, is already bored. He's like, shit, man. Why the hell did I jump on this crap? No, I'm kidding. All right, sorry.
Well, some people say that the secret sauce is really Thousand Island Italian dressing.
Yeah.
But we won't talk about that here.
No.
What do you think about the ideas of you talk about this idea of macroscopic quantum phenomena?
Coherence. Look at slide 8. Look at slide 8 in that AIAA slide paper that I send you. Look carefully what I exactly look at the wording and look exactly what I'm talking about. What we're trying to do is make sure maximal entropy is never achieved. Once you do that, it's as if you are not allowing the physical system to come to an equilibrium state. Everything in so-called life is based on an equilibrium value. But remember what Kerson Huang said about equilibrium and about all this dark matter stuff being out of equilibrium phenomena. You see, read that book. Please read that book carefully. A Superfluid Universe. I bet you maybe 100 people have ever read it, okay? But I guarantee there's some beautiful stuff in there that we can use. That's all I'm gonna say but you'll see what I mean once you start reading, especially toward the end, the dark matter and dark energy part. There's a chapter on it. Read that carefully. Really carefully.
Superfluid.
And have your mind on the Pais effect while you're reading it, and you'll see what I mean.
The first superfluid, I think, was helium-3 or
wasn't it like liquid helium?
Liquid helium, right? Yeah,
I think so, right? Because that's how Kamerlingh Onus came up. I mean, he got his Nobel but he was doing superfluidity of liquid helium before he found it was superconductive. He got his Nobel for superconductivity, right? Yeah, I think so. And BCS in 1960, they got it for the theory. The whole idea of Cooper pairing. I want to hear your take on Cooper pairing, on Leon Cooper's idea of electron pairing. Do you think it has, Dave the physicist, do you think electron pairing has anything to do with high temperature superconductivity? Or do you think it's something that only
I don't know exactly what's going on. I mean, here the big problem is trying to figure out what is the mass of the Cooper pair. I know that's a big mystery with it. So yeah, I mean, I feel like we just don't really understand exactly what the true theory of superconductivity is. I'm not a condensed matter guy, so I don't have strong opinions on what it should be. but it does seem that there's something to figure out there. Maybe is gravity related or not to figure out that mass difference? I'm not sure. I don't know what to say too much.
That's a good point. That's something to be looked at. Jeremiah, did you read the Victor Lachno? I know Michael Perrone has read it. Have you read the Victor Lachno paper on high temperature superconductivity?
I haven't.
The mechanism that the Pais effect. Yeah, go ahead.
Not yet. I haven't read the paper on it yet, but I do have an operational sort of intuition about Cooper pairing and room temperature interaction.
Look at the last page. What he says. He says Pais may use an alternating magnetic field, right?
Well, if I could suggest something too,
which is interesting, to disrupt the surface superconducting layer, hence creating a Bose-Einstein condensate. And then he uses what? An alternating current. I can almost hear Dollards right here at the back of my mind. Alternating current to do what? To cause dynamics of the Bose condensate.
Right. If we get two electrons, right, and we get them to phase synchronize or couple, quantum entangle, what's going to happen is the two spins are going to oppose each other in terms of producing an interactive magnetic field as it's flowing through the conductor. So even at room temperatures, this randomized conductor, which would normally
slow down, please, for me.
Sorry. Okay. So so at cold temperatures, when you have an electron flowing through, its electric field is going to follow its attraction to all the unpaired spins or any kind of imbalanced charges surrounding the nucleons and the electron clouds, right? So it's gonna be predominantly following a pretty linear path, and once it cuts through, it's gonna spin polarize the surrounding electron valences through their interaction with the nucleons to create a pathway where it can now tunnel. So once you get one electron to do it, then the next ones can do it very easily, and so they'll link closer to each other and spin polarized. But
so it becomes like a giant matter wave. It becomes
a matter wave, right?
That's where the coherence comes in.
But here's the room temperature part. So this is where it gets interesting.
Right.
You don't have to have super cold materials in order to get this phenomenon to occur.
As long as that piezoelectric material, right? PZT, lead, zirconate, titanate, all of them, lead, zirconia, and they're all what? Low temperature superconductors. So you need them. You need them to be superconductive at low temperatures. And then you bring the TC up by this mechanism. I'm amazed that this, this guy's Russian Academy of Sciences. How much you want to bet there are a lot of scientists out there, okay, in certain states that I won't name. There's no need for, this to be taken down later. So that are looking at this stuff very carefully, if they don't already have it.
They should be.
So basically, it's a 4-ket superconductor, right? So it's a driven coherent state, and it's a Bose-Einstein condensate, and you're using bipolarons instead of.
That's exactly what Lachno's talking about. Bipolaron mechanism. It's not It's not the Cooper pairing. Correct.
Yeah, it's
or not the traditional Cooper pairing, at least. I'm sure you still have bosons.
No.
It's like a short horizon entanglement. Yeah. So
it's
that's
definitely a nuance. Cooper pairing somehow still links to it. It's just another level of it. But yeah, and Leon, what an idea! Who'd have thought? Think about it. The electrons overcoming their Coulomb repulsion to pair up, do a dance together. That's effing brilliant.
Phenomenal. Yeah, exactly. And they naturally do this when you get them to interact at just the right angle, and they have an almost equivalent velocity. If they cross
a mind like that, we need in that MMA cage, and we don't let them out until we convince them, one way or another. Combat of the mind, baby.
Seen it. Okay, we've already seen combat of the mind. So to prove the point that you can have room temperature like superconducting states, we've already seen it in boron and in carbon nanolayers, and just by changing the interaction angle of two different lattice grids, we can now create these magnetic moments which allow that interaction to occur. The interaction is rare, but if we can get two electrons that are traveling across at some angle to each other to actually link up and get their spin states completely crossed so that they entangle just for that moment, it's like a short information horizon synchronization. It's not technically superconductivity. You have still two independent electrons, but they are spin synchronized, so they're more, their interaction with each other is stronger than it is with the rest of the lattice. Hence, they experience no resistance.
Given that physics, how would you explain the Meissner effect, though? Given what you just described, how would that particular structure you're describing make sure that no external magnetic field? I mean, it still penetrates up to the London penetration depth. It still does. Everybody talks as if, it's total expulsion. No, it still penetrates. But we're talking about microns, right, Michael? We talk about microns. We're not talking about freaking So
it goes from having a wave equation solution to a what was it? Laplace? No, that's not. That might be. Well, it's got exponential solutions. It's got evanescent solutions, I should say. Not.
Which brother came up with that? Was it Fritz or Heinz? It was one of them. There were two London brothers. You know that, right? There were two London brothers. Yeah, both of them really high up. But anyway, yeah, it's pretty cool how they were able to show macroscopic quantum phenomena. That superconductive, right? That's pretty cool.
It's amazing how far apart you can get two electrons and have them still stay quantum locked with each other. It's shocking. Once they get locked into that state, they seem to be interacting almost at superluminal velocities.
That's weird, though. Why 3? Why not 4 or 5? Why the number 3?
That's a good question.
Dude, man, listen to me. Tesla did not believe in the number 3. Remember what he said about 6, 3, and 9? And all those numbers are divisible by 3. So again, 3 at the basis. Tesla did not believe in the number 3 for nothing. But I wonder if he ever wrote it down. His philosophy of the number 3. It's powerful as hell. I mean, look at the other dude. What's his name? The one with the Pauli exclusion principle. He was crazy about understanding the fine structure constant. You know what I'm saying? There's a philosophy to these numbers, man. Look carefully at 1 divided by 137. Put it in a calculator. You'll see what? 0.007299, and then the thing like repeats the other way. It's like a freaking vibration almost, like an arithmetical vibration of sorts.
Well, any
Put it in your calculator, 1 divided by 137. You see what I'm talking about.
Any rational number will do that, though.
One reason why he might have been all up into the 369 numerology, though, could also be, I'm throwing this out there, the universe as an information computational machine happens to run on a ternary-based system.
There you go.
Well, I mean, if you think of particle collisions, technically you can only have vertices with 3 edges connecting to them, I think.
Yeah, Feynman thought this was a magical number too. Yeah.
And there's 3 Whittaker potentials, even though it was claimed that 1 was unphysical.
Yep.
Yeah, there's something very interesting.
Man,
What do you guys think about Frank Wilczek? The whole idea that the materiality of the quantum vacuum. Ain't that? I mean, the guy. Did you ever see him go against Lawrence Krauss? Everything came from nothing, something like that. Did you ever see?
I think I might still have to watch that one.
It is heavy, bro. You gotta watch it.
He said we're children of the ether at one point.
One of the best. Yeah,
that's
amazing.
I mean, this is the inventor of time crystals, but dude, listen to me. Wilczek has a mind like, I think, in my opinion, he's the best we've got right now. And I'm sorry, Nima Khani Ahmed, I always thought you were great, but since you never answered my emails, I'm kidding.
Better than Ed Whitten.
Anyway, that's funny. Anyway.
You're more scared of Wilczek than Ed Whitten?
Oh my goodness. I think Whitten would give me a headache. He is the most mathematical person in the history of physics, in my opinion. Even, did you see what Eric Weinstein has to say about Frank? Not Frank, but that. I don't know. I regard Wilczek as the greatest but that's me. You know, what's the
I was
name?
trying to get
Did you
Eric
see what he
Weinstein
says
to
about
explain
yeah, Weinstein is pissed at Witten for supposedly and Dave the physicist know what I'm talking about, for slowing down the advent of physics with string theory. Really?
Yeah, but I mean,
got
he's just trying his best. I mean, at the end of the day, everyone's just trying
I
to do
remember
what they
who
can.
his father was, Lewis Whitten.
Lewis Whitten.
Hey, right there, Jeremy, you've done the research. You know who Lewis Whitten was.
Yeah, they were the father-son team for Martin
One
Marietta.
of those quote-unquote guys that kind of in the 50s just kind of like, whoo, what happened? Remember, you know the names. Was it the Bobson or remember the quantum
Bonson Labs and
Kurt Mongol has a thing on his theories of everything with this, with the
Bonson, yep, the
with
history
quantum gravity, the mystery of quantum. Yeah,
yep.
Very interesting. Very
really
interesting
story.
I
They
mean,
put
you
tons
have
of money into this.
Top physicists, okay, work on this. I mean, for God's sake, we talk about DeWitt, we talk about the Wheeler, the Wheeler DeWitt equation. We talk about Wheeler. I mean, this is John Archibald. You know, matter tells space-time how to curve, and how is it? And space and space-time. How does it go? And space-time tells matter how to move. Something. I would replace the word matter with energy density, and I would do something anyway with fluctuations.
Sure.
I think it's in one of my slides, but that's the only thing that I would ever change on that was beautiful.
Well, that non-Riemannian geometry that Eric is interested in is also in string theory, but most string theorists don't even realize that either. So
yeah, good point.
It's they're not as far away as it seems. In fact, it turns out that Eric Weinstein was actually influential to finding a solution to the origin of M theory, but I don't think either Eric or Ed Witten are aware of that in detail. So I don't know.
Really? You should reach out to Weinstein and let him know.
Yeah, I've talked to him a couple times.
I mean, for God's sake, the way those remember that crazy paper that they try to publish on Archive with this guy? He wouldn't even give his real name. Called himself Theopolia.
Oh, like, yeah.
The god of everything. It was some weird translation. And dude, what's up with these people, man? I mean,
well, he's a real person. I talked to him.
Now the other guy, Timothy Noon, he is a really good physicist. I've seen certain things. I mean, you know what I'm saying? But give Weinstein a chance to respond. Don't attack him in that manner. You just don't do that. You know what I'm saying?
Too, you mentioned this guy with a name. People have said like, "Oh, Salvatore Pais translates to "Savior of our Nation," and that's not
my God. Yeah. Thank goodness they don't remember my middle name, because my middle name is Cesar, in the Romanian for Caesar. That's all I need, you know?
Yeah.
Forget about it. Look, I do believe that a name is everything. In Latin, it would be like patum meum nomen est. My name is my destiny. But, you know, that would push the degree of hubris so high that these people would explode just by reading. Hey, maybe that's not a bad idea. Anyway. Again, let's try to use creation, not destruction. So anyway, yeah.
There's only one name, the Sarfati.
The Sarfati, dude. I like him. I tell you, I really like the guy, but the way he attacked, especially the craft using an inertial.
It's hilarious.
Oh my God, when he got I mean, come on, man. I was already in the doldrums, you know. He freaking, you know. Anyway. Thank goodness that that's
his approach to everything. So it's like it's hard for other people too, because it's like, well, there could be other legit theories.
Bro, he's a nice guy. I know deep down that dude is not a nice guy. I just have this
feeling. Seems he's old, and it's just like he's on his one path, and if it's not super relevant to his path, he's just like, forget about it, or just done with the schmucks, right? So it's like
that's
super relevant.
But you're right. You're right. It depends on how he says schmuck. I've heard him say schmuck in a nice way, and I bet you he didn't mean that. So yeah. Sarfati is someone that can be dealt with. And I think so can Eric W. Davis. I'll never understand why EWD, dude, the way he attacked my work. That's why the Senate Armed Services Committee basically stopped completely. They were gonna do all kind of stuff that I can talk about because stuff. But anyway, he just reached out, said this is complete garbage, complete bullshit. Boom, gone. And he reached out to one of the most influential people out there. And you know who you are. His initials are JS. I'll stop there because we talk about O and I and above. Yeah, another 3-letter wonder. But anyway, I almost started working for them. That's a different thing in a different lifetime. Maybe in a parallel reality, I'm already the director. By the way, hey, what do you guys think of this Arrow office? What's your take on it? I really want to hear.
Seems like a bureaucratic thing.
Sorry. The idea that looking for anomalies, that we have to resolve aerial anomalies, it's just not the right approach to the science. I think we need to be looking more at the trillions of dollars in unaccounted for black budget programs in this country. We have stovepiped operations that potentially have the capability to hide the existence of aliens and alien technology, according to some of these whistleblowers and people that have come out in front of Congress. And I believe that they have the capacity and the capability to keep secrets of that magnitude. And that's something that shouldn't exist. So I don't understand why we need, why we're looking in the sky to try to resolve aerial anomalies when the real problem, it seems like, is, you know, well, where are these technologies and how do we make sure that, you know, the American people get this access to this technology before, you know, Trump or a Biden can go and outsource and sell the secret documents to China or Russia or something. You know, that's what I'm worried about is how do we get this in the hands of, you know, people
individuals that can make progress,
yeah,
real progress, not the bullshit they call progress.
Can I also answer to the question about Arrow? So we've dumped a huge amount of money into an observation program, and I think the big question we have to ask ourselves is, what has the Arrow program done to benefit the research efforts,
the physics,
the scientific community, or even the military research, right?
You guys have done more at APAC, putting certain ideas forward than, ain't that some?
Right, it's
and
like you gave them lots, and what are you getting for it, right? What are you getting for it?
What's their funding?
It's a political thing, yeah. Arrow is a political tool, basically.
Yeah, our money disappears into the program and nothing comes out of it. That's the real problem. And so it's sort of just like a financial black hole at this point. I'm not sure that we need it anymore.
It manufactures a narrative. That's what it does. I mean, it's not very actionable on the ground.
You know, another thing
science
that bothers
should never
the
have
this reverse engineering technology is to say that the human species is not, how should I say, imaginative, creative enough to come up with these ideas. As I've shown, and actually the Pais comes out of 1890s physics. You think what Walter Bosley and Dr. James Joseph Farrell was talking about with the Sonora Air Club, NIMSA, and all that, and all these weird airships that use very interesting technology. You are telling me that we must depend on ET technology to progress? That's like a slap in our faces. We should be very
stupid to figure this out, right? There's no way. You had to have copied it from aliens. Come on.
Well, I am 100% sure we can do it. That's what I'll say. Absolutely. As a human species, we might be monkeys banging rocks together, but I'm sure we can do it.
In his soul of souls, believes the same thing. And I know Dave, the physicist,
you can feel it.
But he has the math to prove it.
Yeah.
So
you know when you've seen these weird anomalies and they just, even if you've only seen them ever once, like something opens up in your mind and you're like, oh, wow. Turns out that impossible thing actually does happen. And so for the rest of your life, you may see something once and try to talk to all the physicists and all the professors in the world, and they'll all tell you that's impossible, it can't happen. Look at the mathematics. Here's 10 books.
There are no impossibilities. There are no impossibilities, just conditional possibilities.
Exactly.
Everything is everything and all is possible under certain conditions. The trick is to know how to engineer those conditions. That's where you young minds, you people of the future, okay? Because I've eaten my bread. Who knows what my end will be? But anyway, you guys are the future. Take it toward the next step. Don't depend on anyone else. That's the bottom line.
Yeah.
Do it, brothers. But be careful how you talk about the results.
Right. Well, I mean, to all the naysayers that want to stay locked into an old paradigm.
We are not here to enlighten and educate the enemy.
Right.
EQ. We are not here to enlighten and educate the enemy. So be careful. That's all I'm saying.
Can you say anything about who this enemy is specifically, or?
Yeah, I was wondering that too. Is it
you're
ally?
No, listen, we are all Americans. We are all United States. Dude, I love this country.
And Canadians, but luckily allied countries, Canadians and Americans, all allies.
There you go. All right. I don't know what to call us, but you know who I'm talking about when I say no, I'm not talking about the 3-letter. You think they're part of us, man. Okay, that's the.
But what about enemies within, though? Like you mentioned,
dude, I'm not
like
talking
Jeremy
about.
Mentioned.
What?
Yeah, well,
like Jeremy mentioned, the enemies within, like the people like the Bidens and corrupt.
Unification. The problem that we're facing now is because we're so freaking polarized. Oh, I like this. I like that. Deep down, we should unify. That's the only way we're gonna survive what's coming, brothers. There's so many, and you know what I'm talking about, that have us in the crosshairs ready to pounce because we're filled with natural resources. We're at a perfect position. This is an island, but you think it cannot be invaded? Think again.
There are no enemies here. Just Earth.
Again, there are no impossibilities.
Not here.
We must unify and work as one Superforce. That's the bottom line. Yeah, why not?
Yes.
This is
how do people join Superforce?
I'm apolitical, but from this point of view, I am political.
I love that.
Unification. Unless we come together, we shall fall apart. Period.
I agree with that.
FDR knew that, but was it worth it after the war? Well,
it's the only way, brothers. It's the only way. We put our differences aside and come together. Otherwise, we will not survive as a nation. You would not believe what's out there. And it's not.
Do you believe that we should have, our government should be having like a Manhattan Project 2.0 to develop this technology?
If they don't have it already, they should be generating the next Teleulam device. Need I say more? You know what I'm saying? Something that whoever it is has to come at the negotiation table. It'll bring on a new epoch of deterrence. You tell them such and such a device, if it does exist, it'll snuff you out of. So, your choice, because no sane nation is suicidal, and insane nations should not exist. Period. Okay, I've said my thing. Jeremy.
Problem is, if you have an insane nation and these weapons.
I'm pretty sure they're going to kick my ass for this, but F it. I got to say my mind. Otherwise, I feel like the slave. Anyway.
Well, if you get fired, we might be hiring. So.
Hey, brothers, and then, no, but trust me, they would take me out of commission before. Anyway, I'm not going to go there. I hope.
I don't see how if you have an insane nation or a one.
I hope our guys, the good guys, understand my worth and you guys' worth, and have a good place for us rather than, because oh my goodness, if that's not the case,
here's hoping.
But if it's true that we do come back, F it, I come back, and this time I'm a supermodel. Nah, anyway.
Hey Sal, so jokes aside, though, if we happen to be able to get funding to be able to put together the dream team, and be able to realize some of your ideas, I got two questions on that. One, would the heme fig be your go-to experiment, or would it be a different one?
Nah.
And two, would you be willing?
The superconductor would be the first I would try, but
would you be willing?
Too. But the room temperature, see, that's the thing, man. as far as I'm concerned, I work for the good guys. So until my boss comes to me and say, you know what, there's a skiff for you or whatever, a lavatory in a skiff. Ain't that something? That would have to be a big skiff, what I have in mind. But anyway, here it is. Assemble a team. If you guys get a call, don't look surprised. But I am saying, what I need, we need people that do away with the box, brothers. F the box. I'm sick and tired of hearing, thinking outside the box. That's not good enough. You do away with the box. You start something totally different, a new physics based on creation rather than destruction. The whole idea of a superforce, not just physically,
instead of a box, a vortex, for instance, like a different geometry
and we gotta
to begin with.
Vortex dynamics. We got to go back to the physics of vortex dynamics. That was too easily snuffed out of existence by certain mathematical progenies. Enough. Let's go back to real physics, bros. Enough mathematics.
So,
do some physics,
more mathematics. Yes.
So a private sector skiff is still out of the question.
Only if it's backed up by government, like some sort of CRADA or something of that nature, where I could be the government rep. But man, look, the truth of it, I really, in my hearts of hearts, you want to hear what I really, I do.
I want to hear exactly what you have to say.
There was a time that I hear, as long as some footnote over there has down the line, it doesn't even have to be within the next 10 years, but down the line, this crackpot was not a crackpot, and he was actually correct, blah, blah. That's all I care about. What I care about is that this stuff, and I'm praying that this stuff is already out there in some freaking vault, because I've read a lot of books, military tactics, strategy, history. I do more than just physics. I like to dabble in many things. Call me, again, a jack of all trades, master of none. Fine. But my instinct tells me that what's coming is surreally bad. So I'm really hoping that in some bowl somewhere, this physics already exists and we're ready to put it out and basically slap the enemy around a little bit, just a little bit, and then slap him some more to make sure he never does it again. That's my hope, that this stuff already exists. Because if it doesn't, brothers, you guys better work really fast, because we don't have much time.
There's been plenty of higher level folks who have hinted at the actual existence of what you're talking about. And they've even hinted at it during superpower versus superpower talks, like, hey, we have weapons that you can't possibly fathom. So, nukes are off the table, obviously, because we got something even better.
Hallelujah, man. I hope it's true. I hope it's true. I get so, again, my daughter keeps saying, Daddy, you got to be a little more positive. I don't see it. My instinct tells me we're about to hit the abyss of cesspool time.
What did Einstein say?
I hope I am.
Empires rise and fall, but
sorry,
you gotta. When things change, you just gotta take care of the people around you. At the end of the day.
Right. Yes, but again, we have, look, man, unification. Do away with this polarized stuff. So what if such and such has this belief and you have this belief, and I disagree with something Jack Sarfati said or Eric W. David? We're all American. We all want this land to progress. We have to come together. Put aside our differences. We have enemies out there that would, in a second, not even a second thought, that's the hatred that can be weaponized against us. If we don't unify, it's over. There won't be a United States 5 years from now.
SDI,
my instinct tells me will happen. I hope I'm totally wrong.
The Cold War did not end because SDI was a failure. The Cold War ended because the SDI program was a success.
Again, physics of creation, not of destruction. But first, we have to win a certain
competition,
combat of sorts. It's far above. I'm so sick and tired of your peer competitor, adversary, whatever, the other one, near peer. What's up with this terminology, man? What's happened to the good old Karl von Clausewitz Total War enemy? Because that's what we're talking about. If you around the bush and treat them like they're freaking cream puff, then you're gonna fight it like a cream puff.
As Liminal has said many times, and she's known
these are effing black bears that are coming toward you.
Oh,
and
yeah.
all you got is a toothpick. What you gonna do?
Liminal has
You
said
know,
that
actually, I saw a black bear in the forest once, and it was definitely thinking about attacking me. So I took out a San Pellegrino bottle and blew on it, and it didn't know what the heck was happening, and it ran away.
Sounds they don't understand. Yeah. You can, yes, most definitely. See, again, asymmetric. I love it. The way you think. Again, new methodologies. It hasn't all been tried.
Yeah.
And remember one thing, they forget that Americans are very effing creative. So come at us, mother. Okay? Come at us. And you'll see some surreal. I'm still hoping somewhere in the vault we have the secret sauce. You know, I'm still praying for that, because it would make things so much simpler. You know, a certain
in your
switch is
opinion,
down.
are the Tic Tacs potentially American AI technology,
Oh,
or do you believe they're off-world?
If you look closely at the narrative, especially with the Air Force personnel coming, you kidding me? Have you ever been on board of a carrier? Have you ever been on board of? Oh, dude, man!
I'm a poor Canadian. We don't have them, sadly.
The idea of someone from another armed service coming to your vessel and basically commandeering you around, dude, man. The captain of a vessel is God on that ship. So the idea that these people had the power to remove all these drives and stuff, that basically says unacknowledged effing object. Thank God. So yeah, I'm praying, but I have a feeling. I mean, come on, man. Look at the four protrude. I mean, come on. Those are.
Again, the U should be changed from unidentified to unacknowledged.
Unacknowledged effing objects, all right? Jeremiah, and you know what I'm talking about. Remember those protrusions, those wedges? You know what that speaks to. I mean, how would you communicate with an object of that nature? Especially if it does what it does. It would need something very special.
Oh, yes.
You would use
those little fluctuations in the refractive index to talk to it.
Anyway. So what I'm praying for again, that somewhere in the boat has the secret sauce. And this way we don't have to go through the, through the misery that war creates. Because total war, brothers, I mean, holy. Anyway, you know what I'm talking about. Yeah.
And especially once you have the bomb, that's a whole different level of war than anything we've
Again,
seen.
when you have something of that nature, you don't even need to fight a war. There's basically winning a war before war is fought. You come to the negotiation table. They bring their best physicists. You bring your best physicist. Oh, talk about weaponizing physics. I mean, the physicist being weaponized. You bring them, you say, this is what I've got. Their physicist takes a look. You see all of a sudden droplets of sweat coming from the eyeballs, coming from the nose, coming from the forehead. He looks over at the military commander that he came with, he said, and he says something in that specific language. The military commander salutes, walks out, and all of a sudden you see the political representative coming in and say, we're now friends. Why? Because you don't have a choice. That's the kind of thing. That's what we need. That's why we need something that can solve this at the negotiation table before one woman, one child, anything is snuffed out of existence. Now that is what I would call great physics. Something on the order of the Teller-Ulam device, you know, something that
This reminds me of the whole, I don't know if you've seen Oppenheimer, the movie, but this is like the whole debate in that of like, do we use it to, this will actually save lives if we use it in the timely fashion, and the arguments that they had to go through.
It's a new epoch of deterrence. Again, remember what I said. No sane nation is suicidal. And an insane nation must not exist.
However, if an insane nation does exist and you do have these weapons, how do you deal with that then?
You're a smart dude. I know you know the answer.
Yeah, it's not pretty, but hey, I guess not all things are. My favorite part of the Oppenheimer movie, though, is
you tried to be human. That's all we can do is try to be human.
Remember when they
and if the response is inhuman, how do you deal with it? Do you just cower back? Do you put your tail between your legs and run home to mama? What if mama's not there?
There's an episode of Stargate you should watch, The Nox.
Sometimes you gotta play the trump card. Anyway, oh my goodness.
I'm somewhere halfway between that perspective and the other, because there's two extremes. Either you go in with a knockout punch, instantaneous success, or you change the dynamics of the power structure so that there's no longer any motivation.
Can I explain how they did it? Let's explain how they did it in Oppenheimer, because Oppenheimer, they had all the physicists writing out all the equations on the board, and then they went through the math and they said, this is impossible. It can't be done. And then the guy came in the room and said, hey, they're doing it next door. And that is where the moment where the physicists in the theoretic room were like, oh, well, maybe we made a mistake here. There's something wrong, because Fermi and his counterparts, Enrico Fermi, were doing it.
Man, Fermi have.
So it's
those guys, man. The Hans Bethe, Hans Bethe was Sarfati's mentor, wasn't he? Who was Sarfati's mentor?
So he claims.
No. Trust me. That dude. One thing about that Sarfati, he knows. He knows his stuff inside out. I take my hat off to him. I just wish he didn't call me an idiot to my, anyway. So, but what I'm saying
is, it's an honor to be called a schmuck or an idiot by Sarfati.
Yeah, really? Damn.
Only when he's smiling. Only when he's smiling. What it means is
smiling schmuck list.
I can translate the smiling schmuck. Okay, and what it means is you're onto something. And I'm glad I'm going to figure out the math before you.
They're our guys. So okay, that's the bottom line. They're all good guys. Jeremiah, they're all good guys. They're our guys. These guys, okay, we would, trust me, if the enemy all of a sudden showed up, how much you want to bet we'd all put our differences aside, solve the problem, and then once it's done, we'd come back to ourselves, and Dave would tell me, your math sucks. I said, yeah. Remember how I saved your, when that guy came in, and he'd be like, okay. Maybe I'll write a paper with you and show you how it should be done. There you go. So what I'm saying is, the bottom line, we come together.
Right. Let the engineers build things. Let the mathematicians figure out the equations. Let the physicists theorize about how all these things intersect together. And everybody do what they do best, but let's not be at each other's throats, because an engineer only with no mathematical aptitude whatsoever, but the ability to fix anything by practically looking at it, and the guy who can think in numbers when he dreams but couldn't build a thing to save his life, when they work together, right, what happens? We have this unity all of a sudden of a full explanation plus a physical apparatus that's experimentally verifiable in the lab. And it is in the unification between.
I must agree. Experiment trumps theory every time. I 100% agree. But remember what Dirac said about experiment. He said sometimes the beauty of the mathematics should precede. Because one thing about experiment, you got to be careful with experiment. It has to be under certain correct condition. Sometimes people, for example, okay, let me bring a very interesting experiment that's always intrigued me completely. The Hayasaka Takeuchi experiment. Remember the rotor that all of a sudden lost weight? It always intrigued me. Those dudes got published in Physical Review letters. It was a December issue. I still remember. So maybe the guy was trying to get home to mama, because she cooked really good food or something and just passed the paper. That's possible too. But I don't think so. I think something in that paper spoke to the editor that said, okay, we'll pass this. All right. This is Physical Review letters. This ain't, Mojo's excursion into physics, We talk about the greatest of publications. Look carefully at that experiment. There's something they did, and I think it has something to do with cold plasma. Look what I say in my paper on the hybrid aerospace undersea craft, that AIAA space paper from 2017. I have some brief stuff on Hayasaka Takeuchi. And it speaks to some lecture notes from Kip Thorne. Ain't that interesting? Kip Thorne. He's a gravitational guy, huh? But going back, okay, now I'm jumping from here to here, but I'm trying to connect the dots. Sometimes you got to jump. Anyway, remember the 1950s, all these great physicists? We talk about Lewis Witten, Edward Witten. I remember him saying the one true giant that he thought was much better than him was his father. So we talk about one of the greats that ever lived. We're talking about the DeWitts. We're talking about Wheeler. We're talking about who knows who else. Feynman for sure, because if Wheeler was involved, so was Feynman. But anyway, so, and all of a sudden this thing goes dark. You see what I mean? Too many things that don't make sense. Hayasaka Takeuchi, within 1 or 2 months, 3 or 4 papers, 2 of them, I think, in Physical Review, another one in another great journal publication came out. Null results. Then two more within a matter of 6 months. So almost like 5 or 6 papers within 6 months.
Sounds like what happened to Scheuer. Robert Scheuer went through the same thing. First it worked, NASA's talking about, hey, success, and then it was all null results. Oh, test measurement error, right? So, I mean, it could be.
One guy, one guy that scares me, that at night I'm like, I wonder where he is. I wonder how much money he has, what kind of teams he's with him. In Russian, his name is Evgeny Podklenov. Remember him? Eugene? That's the name of my uncle, so I have great admiration for that name. That my uncle meant a lot to me.
I've deeply studied his
gravity
impulse beam. Deeply studied it. I mean, I would love to talk with you about the physics of that at some point. It might be something off the air.
That interview with Podkletnov wouldn't exist if I didn't put it on the internet.
Yeah, dude, your stuff is epic, and it has been.
Worked with Evgeny, especially Dr. Ning Li.
And she was the one that actually developed those special superconducting materials. She was the, she was the Dragon of the West, in a manner of speaking, the real brains behind the material science.
That's why I hold Jeremy in such great admiration. His research, bro, the way he's been piecing these things together. You see what I'm saying? And I tell you, brother, you have some high-level enemies, bro. That's all I gotta say.
Yeah.
I'm pretty sure, so do I. But look, they say that the quality of a person is recognized by the status of his enemies. So if we didn't, that means we're not worth anything. So cheers, my brother.
Sal, you were mentioning...
This is water, by the way. For your information, this is water. YouTube, this is just water.
Sal, you were talking about...
I'm kidding. Go ahead.
You were mentioning about... about patents going dark. And I just talked to an inventor here just a week or two ago who has submitted multiple patents that they all end up going dark. There's something like 8,000 or 10,000 different dark patents. Your patents had the special aspect of them that they went before multiple, Navy review boards and high-level review boards, and yet they still didn't end up going dark. Why do you think?
Even after the Senate Armed Services Committee sent an all-day team to investigate, they still didn't go dark.
Do you have any ideas why they didn't?
Between you and I'm so glad because I want the enemy to think this is disinformation. Even though I say that I want to be vindicated deep down, man. Look, if it's between us winning the war and me being that effing crackpot, I choose winning the war every freaking day. Because I'm American at heart.
Ending all war permanently across the planet. That would be goal.
It's our made in Romania apple pie, American pie.
American apple pie made in Romania, baby. I'm very proud of my land of origin. I'm very glad that Romania is where it is. So, anyway, so very proud of being American and very proud of being Romanian. So there you go.
Can I follow up on that? Have you submitted any patents that did end up getting taken and had to go dark?
Again, I quote on Ashton Forbes, I said, I will not lie because layers upon layers upon layers of lies masquerading as truths should not pass go. So I will not lie. No such thing. As a matter of fact, I think they were very happy with me not doing anything else after those 5 things went through. Because I think I'm the only one that was able in front of, these are, dude, look up NAVID technical fellows. These are no mental midgets. These are no cerebral troglodytes. These are the real deal. If they pass muster, every one last of them, that should tell you something right off the bat. Actually, when I was given the talks, and we had multiple meetings, that's what keeps me going. Remembering the faces of these ladies and gentlemen in the room and certain flag officers. Thank God we have these people around, bro, because that's how we're going to survive what's coming. They exist. Thank God for them. And that's what I'm saying. The one weapon that they do not understand, and it's fueled by the way we were brought up, is American creativity. And I really, really pity the enemy that goes against us because that will live on forever, bros. And even if we take a beating, because sometimes you lose the battle, we shall win the war. And that's a prophecy.
Amazing.
I know the last prophet and stuff, but
I think we're at 3.5 hours, Sal. This is a record for you. You want to go to 4, man? I'm down. But I think your cap is like.
Are you kidding? Holy shit! Oh, sorry. Maybe
24 minutes. I think we should make it go to 4 hours, and then I think we got to have Sal back for another episode and have Sal on APEC. Sal deserves an APEC as well.
Now we're not talking. Okay, let's not talk physics. Let's talk, for example, what would you do with this? Oh, fine. What would you do if you were to come up with these physical ideas? What would you do to advance American science toward keeping our superpower status forever? What would you do?
That's a tough question. I would recognize. How do you get it to not turn tyrannical if there's only ever one power?
May I? I actually have an answer to that question, Sal.
Remember what we are. What is the American democracy? It's truly a republic. But we elect the people that represent us. Therefore, at the bottom, the people are the leader. This is the beauty of this country. No freaking oligarch is going to make a call and make you.
Well, unless you have manufactured consent. Civics is no longer a class in school.
We're still
It should
free.
be.
But anyway, what would you do to advance civilization? Not just American, but civilization. How would we break the bounds of Earth and become an intergalactic civilization?
We would have to first solve the major problem of scarcity.
Post-scarcity is more important. Post-scarcity is more important than getting to space right now. If we go to space right now and we don't have a post-scarcity civilization, we'll just bring all our problems with us. We'll be able to escape the gravity well of the Earth, but we won't be able to escape human nature.
We'll be doing what the Indian Independence Day
So
did.
rockets are definitely not the solution. Agreed?
Well, neither is anti-gravity.
I completely agree. Rockets cannot be the solution.
Maybe as an initial phase, fine. But it should be a bridge, and more money should be put, or more funding should be put toward the advanced technologies. You cannot tell me that the only way to move a craft with space-time is to throw that freaking fecal matter outside the nozzle. No,
yeah,
I refuse to believe that.
Yeah, if we can't clean up Earth, then we're just going to make a mess in space.
Oh.
Yeah, post-scarcity is should be the first
You might
objective.
not like this,
and
Dave,
people
the
think it's harder.
but there's a philosopher inside of you. Dave, the philosopher physicist. Whew. Nice. Very nicely put. No, for real. Very, very nicely put. Very nicely put. So good.
Yeah, we have to figure out post-scarcity first. It's at the end of the day. That's the key thing. If we're gonna have all these godlike technologies, we better have the wisdom too.
Yeah.
I think transportation is key. It's not to get out of the scarcity. It's not that just that we have enough stuff. We need to be able to transport the stuff. I think that's kind of the biggest
So
problem.
maybe we should crack, if not room temperature superconductivity, highly efficient and cost-effective high temperature superconductivity. So maybe there's an interim step between the holy grail of condensed matter physics and what we can just to advance the state of civilization. Sometimes you take baby steps, but you still advance in the end, incremental.
I met a man once who came from the future, and he said self-replicating factories. That's a bit of a claim, but yeah.
Self-replicating factories, like
kind of like AI
like
does.
Neumann probe,
become like the nucleus of the cell. We have all this equipment that we're the brain of the cell or the brain of the household equivalent.
That dude that came from the future, couldn't he give you the time excursion, the temporal excursion technology? Because that would solve
this was more important.
Wow.
Because our society is analogous to a slime mold. Each individual unit needs to be self-sufficient, and the whole structure then becomes self-sufficient if we cooperate properly. But right now, the individual units are not self-sufficient, so the system is brittle and subject to many failure modes.
It's deep.
That is accurate.
What do you think, Jeremiah?
I think the analogy to a slime mold, or more closely, mycelium, because we do actually share a lot of genetic structure with mushrooms, the way that they cooperate and collaborate with other structures around them. For example, many will feed nutrients to tree roots while taking away some of the garbage products that they generate and transport them through the entire network. So yeah, the solution ultimately is, I think we solve scarcity by unifying our resources and the brightest people in our societies, instead of trying to say, I did it first. It's more about we did it together.
Do you think we'll ever be able to come together as a united Earth?
I think that APEC is a proof of that. I think that APEC proves that people from all across the world, because we've had people on from so many different countries, and they all came together because we all believed in this one concept that, hey, if we can solve this propulsion problem with alternatives that aren't rockets, then we just might be able to solve the scarcity issues as well, because we can get resources to and from where they need to go at a cost that is far less than the cost of actually obtaining those resources. So behind that, the fact that it came together, and it came together very smoothly, by the way, it was almost no effort. Tim stepped right in, took over mod. Mark and I had no problem bringing just about everybody you could imagine in. I mean, Mark kind of just took the whole list and
I agree.
sent everybody emails at once.
When people have a common objective that is worthwhile, that talks to advancement of all instead of just individuals, you're right. This can be achieved.
I believe in it, you know, because it worked before, because we've seen it. I know that we can actually come together.
That's how I'm able to sleep at night, because I believe one day we will be a united Earth. And guess what? Even then, there shall be an external enemy. What's up with this almost dichotomy between good and evil? It's like for everything that's good, there must be a counter agent.
It's subjective and created by our psyche. You can fight against it. But anyway.
Right. The ego is always going to be in competition with the idea of unity. And some people are going to be controlled by the ego, and they're going to think power for me. And some people are going to be aware enough to recognize the power of unity and realize more for you, more for me.
How do we deal with re-engineering human nature? Do you think that's possible? To make us act
more flexible.
Turn off the television and turn on alien scientists. That's how.
Children are the future.
Have you
Lead by example. That's how.
Have you ever seen ants, how they cooperate? I mean, ants, they can be individual. You sometimes see an ant going away, you know, doing his own thing. But then when they act together, the stuff they can do, they can freaking, a field of ants can carry a freaking dead fox away. Why not?
Be the change you wish to see in the world. You know, Gandhi.
Yeah.
Once we have multiple
that's why we're all here right now, is for that goal and working together and open sourcing it and putting it out there.
See, but the fact that we have to watch every other word we say and be extremely careful not to educate and enlighten the enemy. Why must there be an enemy? Why can't we just come together as one united Earth? I know it sounds almost like, you know,
society's
holding hands and singing Kumbaya, but I mean this seriously. Why can't we just be unified as a global entity?
That'll take a couple thousand years more.
No. If you have multiple generations of people who have all gotten a view of the Earth from the orbital spot there, how all the astronauts come back and they say they're completely changed. They say world leaders should have a minimum requirement of being able to view the Earth at some point in their lives from this, because it's such a shift in your perspective on the world. If you have multiple generations of humans who have been able to view the Earth in that perspective, guaranteed you're going to have a change in the human nature after just a short couple generations.
That's
you remember the way Carl Sagan put it? The pale blue dot. Goodness gracious. Do you remember the old Cosmos episodes before Neil? I mean, the real Cosmos.
When they were
Do you remember those?
Absolutely.
God, I miss that man. Do you remember
I prefer
his
connections with James Burke, but
the language he used? It felt as if it came from his soul. Do you remember? Anyway, all right.
Oh yeah, I can play that whole thing back in my head too. It was such an unbelievably poetic.
Every one of those episodes was special.
It was.
Sal, who are you? I want to hear your top scientists. Anyone else whose work is underappreciated or under reported on that you want to plug for us? Any?
Dude, again, I want to plug some podcasts because they're important. These are either physicists or doctors in material science, astrophysics, astronomy, and they're trying to do something new. Again, Demystify Sci podcast with Dr. Shiloh and Dr. Anastasia. By the way, her name pronounced Anastasia is Russian. It's a beautiful language. Pronounce it correctly. What's this Anastasia? What? It sounds almost like she's going under anesthesia. But anyway, so please kindly pronounce it right. So I think she doesn't mind being called Nastia. That's like a nickname. Like I'm called Sal, or anyway. So So Demystify Psi podcast. Ashton Forbes, please, dude. He is this guy should have been he's definitely a good investigative journalist. Jeremy,
had him on the podcast last week.
I know you and him should cooperate on your research and stuff.
We have to have you, Sal, and Jeremy, and Ashton back on, and bring together also Bob Jr.
Listen, I promise. I'm making a solemn promise. I will come on this podcast as long as you want me, and as long as these guys don't say that you stop and for no other reason that I have a 11-year-old to raise. So her future is far more important than mine. I've eaten my corner, my piece of bread. I've had my anyway. She is what matters to me. So the bottom line is again. Oh, don't forget Jay Anderson, right? Project Unity, and Kurt Mongo.
Yes. Yeah.
Theories of everything.
Here, I wanted to throw out.
Don't forget Tim Ventura interviews, dude. This guy had Lord Martin Rees on, bro. I'm talking about Lord Martin Rees, not. You know what I'm saying? Anyway, I see what he has to say about the future of civilization. It's not exactly a happy space, but anyway, you know what I mean. Like he sees.
I watched your interview with Tim Ventura about 3 times last night, Sal, and I've got 4 pages of notes from it, as well as from the Ashton Forbes. So I'm gonna have to do an episode with you just on those, because my God, are they worth watching?
He's a really good dude. Tim is a really, really good dude.
Also, check out
all you guys have a lot of great. I really applaud. I admire what you're doing, and thank God you guys exist, because this is what I'm talking about: American ingenuity, American creativity at work. So bravo. This is for you guys, alien scientists and APAC. Bravo. So. You guys are absolutely amazing. Thank God you exist. You guys are the future. That's the truth. Look at me. This is. It's not like that I could dye my hair and look younger. Still, I'm of a certain age, but as long as I can say certain things and bring to just a little bit of incremental progress, I will. Just as long as I'm not there to. Unfortunately, I gotta say this, and it pisses me off, because there should be no enemy when it comes to Homo sapiens sapien. We are one freaking species, brothers.
Culture determines.
We gotta come together. We gotta find a way for unification.
That was like the perfect wrap-up, man.
There'll be no unified field theory without unified physics, right? You have to bring all the physicists together to get unified fields.
So if there is a physical superforce, why not a social superforce to unify us all? Anyway, that's just an idea. Jeremy, thank you very much, brother, for having me on. You're a prince. You're a prince among men. So thank you.
Thank you, man. I have some amazing friends. You guys I couldn't ask for better, man. You guys are awesome. And it's just great to have so many really smart people that have come together to give different perspectives and just try to, pick out, whatever we can from this that's useful, and then find out what isn't. And you just try to move this whole thing forward, man. And
but again, we move on with no derision or ridicule toward the people that quote unquote, that we think have so-called failed. Don't use language of that nature.
There's no shame in being
there's no failure when it comes to trying. The real failure is not to try at all.
Yes.
Period. Right, Jeremiah?
Yes. That's absolutely it.
That's right.
Stick it on the lab bench. Find out what happens. If it catches fire, oh well, you try again.
What happened? Like no sisters. I mean, I see only brothers here. No. We gotta get some sisters.
Oh, we got
involved.
sisters.
We have
Don't
some
worry.
sisters
Oh, we got
Greek,
sisters.
right?
It's because it's Sunday. Friday night the girls join, right?
Now,
Okay.
there's a
Oh,
lot.
that's
We have
right,
a lot
that's
of
right.
very bright ladies in this community too. They're not here today, but we should do a
Oh,
whole
definitely.
collab show because
There's a few in
they
the
give
audience.
you that,
I mean,
well,
the ambiance
us testosterone
changes
driven folks.
completely, man. It's like between you and I, thank God for women. Because I tell you right off the bat, it's their compassion. It's their
something to keep us guys on the
Just-
straight and
yeah.
narrow, right?
Otherwise, excess testosterone can, I think I can say that. You know what I'm saying?
Oh yeah, I know
Can lead
exactly.
to
what you're saying.
certain unpleasantness.
Butt in hand.
She's
Let's
here,
just leave it
she's
there.
here helping me today. She's just not on the show, so just saying.
That's right. And
Sal,
Michael
before
had
we
his
go-
daughter, because I heard her, dude, teach her well. She's got a great father. Teach her everything you know, bro. So anyway. And Dave, the physicist, you're the man. For real, man. One of your slides, just one of your slides. God, you're really good. Keep on going. I think one day, who knows, maybe when you become chief editor of Physical Review Letters, I have a chance. But maybe even then they say, man, this is not bad. Come on. just
Yeah, we can talk more.
So let's talk after the show. We're on the hour here, so it's about
let's wind it down here,
Nice to
guys.
meet you.
Thank you so much
All right,
for
Michael.
watching.
All right.
Yeah, stick
All
around.
right.
We'll
Hey,
talk in a
right
minute.
there. Bernie,
Yeah,
you do some
Sal,
awesome
do you
AI
mind-
art, man. Yeah.
Thank
that's
you.
cool.
Do you mind putting your email in the private chat and then I'll
Dude,
email you?
I suck at that stuff. He knows it. Just ask Jeremy.
Okay, I'll
But
get your
whatever
email and
you
I'll
Get in touch with me.
Okay,
Dude,
because
do
I'll
me a favor,
put together
keep
an
it-
episode with Joseph Farrell and Walter Bosley
Okay.
with you as well,
Keep
sir,
it
if you would
fine.
like that.
Oh, I would love. Oh my goodness, I would love that. But listen, I hold both of them very, very high esteem, especially Dr. Oh my God, Dr. Farrell. I have so many of his books. Anyway, the one, Dave the physicist.
That
Check
needs to
out
happen.
Dr. Joseph Farrell's Secrets of the Unified Field. Check that one out. Just I know and all that, but trust me, it'll give you some ideas. You're a very smart dude, brother, and you know this math that will give you rites of passage. So why not use the philosophy of great physics to propel you even further? If you can prove it mathematically, your homeboys can tell you no. But anyway, all right, I digress.
Amazing episode, man. Hey, thank you so much again for joining us, man. You're the real deal for coming on here and putting up with this, because this is like
It's
the
all you,
gauntlet.
brothers. It's all you. I came up because I really hold you in admiration, and I think you are the future. You really, because you don't do this for money. You don't do this for power. You don't do this for greed. You do this because you want to. You really want to advance civilization. So my hat off to you.
Much love.
Love,
Hey,
return, brother.
May the
I
Superforce
love
be
that.
with you.
You gotta tell me where to get. Dude. You cannot send that for free. No, no, man, bro.
All right, I'll let you order
pay
what I'm gonna
money
do.
for it. So you send and tell me where to send the check to the address. I'll send you a check. All right,
Guys,
because
you want to get in
I'm
touch
old
with
school. I
Sal,
don't do crap. Anyway, yeah.
email me, and if you got the credits and the credentials and the chops, man, I'll put you in touch. But yeah.
Yeah, Jeremy, because and God forbid, because you can smell these guys. Anybody
Yeah.
that smells like he's against us, our country and stuff, immediate.
Yeah. Anyone
No
that
need
smells
for that
like
now. Eventually, we'll unify. But until you guys come to the realization that we all must live together, otherwise we shall perish apart. And please, don't try to come against us. It'll be your downfall. That's all. I'm done. Sal out.
Thank you, brother. Signing out. Why don't you play us out, Bernie?
Take care.
Hang
Dave,
around though, Sal,
you
until
and I
after the
gotta
show. Hang
communicate.
around for just a couple minutes after.
Hang
the
around.
show.
Go take a bathroom break. Go feed the cat. We'll be here.
No, I'm good. Yeah. Let me see, because my phone was ringing off the hook when I started talking.
Okay, we'll see you in a couple minutes. Thanks, man.
After the bathroom break, see you in the Sal. Love you all. Thank you all.
I'll be here.